Ladies and gentlemen, it's a very good pleasure indeed for me to be able to attend this meeting. Today, I would like to present my paper, a real-time RGB PAM4 visible light communication system based on a transceiver design with pre- and post-equalizations. Firstly, I will make a brief introduction to the concept and application scenario of the visible light communication. Then, I will illustrate why we employ PAM4 and equalization technology in the proposed design. The third part is the transceiver structure and digital baseband design. Finally, the experiment setup and results will be represented and discussed to show the data throughput improvement of the system. Let's begin. So, what is the visible light communication? Visible light communication is a wireless method that uses light emitted by LED to deliver networked, mobile, high-speed communication. It is similar to Wi-Fi. The instruction of the visible light communication presents a massive expansion of the communication spectrum. Therefore, visible light communication is a promising enabling technology for the next generation high-speed wireless communication. Moreover, it can also be deployed in unique scenarios such as underwater and radio-sensitive areas. It has many applications. It can be used to illumination and communication in the same time. And our monitor can also be used to do the visible light communication. And if we have the multiple light source in our room, we can use it for the indoor positioning. So the conventional visible light communication involves switching LED on and off at a very high frequency. On represents 1 and off represents 0. But the bandwidth of the LED constrains the switching time. So the data rate is also limited. We need to find some solution to improve the data rate. As I mentioned before, the bandwidth limitation is the bottleneck of the transfer capacity of the VLC system. This is the measurement results of the bandwidth of the commercial LED. You can see the minus 3 dB bandwidth is only like 13 megahertz. Actually, for the most commercial LED, the bandwidth is only from a few megahertz to tenths of the megahertz. So there are two methods can be used to improve the data rate of the whole system. The first method is the pre- and post-equalization technology in time and frequency domain. So in the proposed design, we use a one-tap feed-forward equalization and the 3 stages cascaded continuous time linear equalization to increase the system bandwidth. The second method is we can use advanced modulation schemes. So we use the pulse amplitude modulation, PAM4, to increase the spectrum efficiency of the system. Why we use the PAM4 for RGB-LED? Actually, there are two primary ways of the producing white light emitting diodes. One is using phosphor materials to convert monochromatic light from the blue or the ultraviolet LED to broad spectrum white light. And the other is using individual LEDs that emit 3 primary colors, red, green, and blue, and then mix all the colors to form the white light. The phosphor layer of the white LED reduces the LED bandwidth significantly. So actually, the RGB LED has more the bandwidth of the RGB LED is wider than the phosphor LED. So if the RGB LED are used to generate white light, we have the 3 independent light sources. We can encode the PAM4 symbol into the unary code to drive the red, green, and blue LEDs. Then the 3 color LED, 3 colors lights are mixed in the optical domain to generate a PAM4 signal. And how one-tap FFE works. Because of the bandwidth limitation, the rising and falling edge delay of the receiving signal is very long, so it will influence the receiving of the adjacent signal. We call that intersymbol interference. The figure A is a transmission waveform without FFE, and C is the corresponding receiving signal. And figure B is the transmission waveform after reshaping using one-tap FFE. The signal is pre-emphasized. And the D is the corresponding receiving waveform. The falling and rising edge is reduced significantly. But how to generate a waveform like figure B? We will introduce in the digital baseband design. After the motivation introduction, I will present the design of the whole system and digital baseband of the transmitter side, so you can know how PAM4 signal with one-tap FFE is generated. This is a diagram of the whole system. Figure A is the structure of the transmitter, and B is structure of the receiver. Actually, the digital baseband generates 2 pass signal for each LED. One is the main pass data, and the other is inversed and delayed as the FFE pass. 2 signals are combined together to drive one LED. And the optical signal is received by the photodetector and amplified by the transimpedance amplifier. Then continuous time linear equalization is applied to further broaden the bandwidth of the whole system. And this is the structure of the digital baseband. 2 clock signals with the frequency differences of the 20 times are used to drive different modules of the system. The slow clock is used for the PRBS generator and unary code encoder to generate PRBS sequence and encode them into the unary code at the main parts of the driving signal of the 3 LEDs. The fast clock is used for rising falling edge detector to detect the falling and rising edge of the main pass signal. Then the fast clock is used in the rising and falling edge delay module to create 3 pass signal with certain number delay of the rising and falling edge. The time of the delay is depending on the delay number of the first clock cycle, which is controlled by the delay controller. After the inversion, signals of the FFE pass is generated. These slides show the details of the PAM4 signal with one-tap FFE generation. The bit sequences is generated by the PRS generator. Then it is paralleled into the 2 pass, which is the least significant bit and the most significant bit of a PAM4 symbol. Then 2 bits are input into the unary code encoder to generate 3 passes signal. And then the rising and falling edge are detected by the detector module here. The delayed signal with specific delay on rising and falling edge is rebuilt through these detected edges and delayed cycles provided by delay controller. And the main pass signal and the FFE pass signal are combined together to generate the FFE waveform like this. Then the experiment setup is demonstrated. This is the experiment setup, and the signal is generated by the digital baseband here and transmitted to the VLC transmitter with the RGB-LED. The optical signal is received by the VLC receiver. After the amplified, the received PAM4 signal is demonstrated on the oscilloscope like this. And this is the digital baseband. It is implemented on a FPGA developing board. And this is the VLC transmitter. And on the other side, we can see the RGB LED. For each color, we have the 2 LED drivers for the main pass signal and the FFE pass signal. And this is the circuit of the VLC receiver. The photo detector is here to receive the optical signal. And this is the transimpedance amplifier, and this is the continuous CTLE to broaden the system bandwidth. Then the signal is through this interface to the oscilloscope or the digital baseband of the receiver side. Finally, the experiment results and discussion is shown. The measured bit error rate versus data rate under the conditions of the LED NRZ transmission, PAM4 without equalization, PAM4 with FFE only, PAM4 with 1-stage CTLE and 3-stage CTLE are plotted and compared. The x-axis is the data rate and the y-axis is the bit error rate. Under the bit error rate equal to 3.6 multiply 10⁻³ compared to the NRZ data transmission by applying the PAM4 modulation scheme, the highest achievable data rate was increased from 22 megabit per second to 32 megabit per second. After employing FFE, the data rate is improved to the 67 megabit per second, and the data rate can be achieved to the 80 megabit per second after 3 stages CTLE is used. The using of the FFE and CTLE together could have the total 2.5 improvement to the data rate. And this 3-eye diagram shows the effect of the CTLE. And this is the eye diagram, only use the FFE. And after the 1-stage CTLE is used, the eye diagram is open. And after 3 stages CTLE is used, the quality of the eye diagram is very good. Actually, in this speed, if neither FFE and CTLE is not used, we cannot see any diagram, eye diagram. And the Bastard curve shows the quality of the measured eye diagram at 68 megabit per second, which shows a 0.3 UI margin for BER less than 3.6 multiply 10⁻³. Due to the different optical response of the red, green, and blue LEDs, the 3-eye height of the received PAM4 signal were uneven and thus led to a very narrow decoding margin. By tuning the driving current of the RGB-LED independently, much improved PAM4 data I with almost equal eye height can be achieved. Finally, the summary. Firstly, an RGB PAM4 VLC transceiver system with one-tap FFE and three-stage cascaded CTLE is constructed. Second, the rising and falling edge delay of the FFE path can be adjusted independently. Third, independent eye height tuning is supported. Finally, the transceiver achieved 250% increase in bandwidth extension ratio in VLC link using ordinary RGB LEDs. That's all. Thank you.
Good afternoon, everyone. My name is Xu Bo, and I come from the Hong Kong University of Science and Technology. It's my honor to be able to attend this meeting. Today, I would like to present my paper, an RGB-LED driver with feed-forward equalization used for PAM4 visible light communication. My presentation will cover the following aspects. The first part is introduction. The second part is overall architecture of the system. The third part is design of RGB LED driver with FFE. The fourth part is simulation results, and the last part is summary. So, let's begin with the first part, introduction. First of all, what is visible light communication? Visible light communication is using the visible light, which emitted from optoelectronic devices as a signal carrier to transmit data. For the motivation of developing VLC, it is dealing the radio spectrum congestion problem. This picture shows the electromagnetic spectrum, while the existing RF systems are operating within the lowest 300 GHz bandwidth. However, the ever-increasing data traffic for multimedia consumer applications has posed a radio spectrum congestion problem, which requires to utilize the other available spectrum resource for communication, including the visible light spectrum. The visible light is starting from 400 THz to 800 THz, which owns almost 400 THz bandwidth. There are many advantages for VLC technology. The first one is license-free operation, meaning that it can be used anywhere, anytime, and the enormous bandwidth of hundreds of terahertz offers the possibility for high data communication. The second one is compliant with existing infrastructures, meaning that it can take advantage of existing hardware, such as LED lights, to implement a practical system, which makes it really attractive. Compared with conventional RF wireless, VLC generates no RF radiation and EM interference, making it suitable for application in sensitive environments, such as hospital and airplane. 9 offside characteristics of visible light make VLC more secure in comparison to some indoor communication technologies, such as Wi-Fi and Bluetooth. Because visible light can be limited in a well-defined space. Also, there are some disadvantages of VLC technology, such as obstruction by solid objects, and the visible light is also easily to be interferenced by weather. There are many potential VLC devices to support VLC technology, such as smart LED signage, smart LED backlight, and smart LED lighting. They can also be integrated to many applications of VLC, such as smart lighting, smart display, sensing, indoor positioning, vehicle communication, and even underwater communication. So what is 4-pulse amplitude modulation? PAM4 modulation utilizes 4 different signal levels for signal transmission. Each level can represent 2 bits of logical information per clock cycle. In other words, there will be levels from 0 to 3, representing bits 00, 01, 10, and 11 separately. Comparing with NRZ signal, which only transmit 1 byte per clock cycle, the bit rate of PAM4 can reach twice as much as that of NRZ. With the increase of data rate, the channel length used for signal transmission is decreasing, so that the same bandwidth can be used for higher data rate. Therefore, PAM4 owns higher bandwidth efficiency and smaller channel noise. The second part is overall architecture of the system. This is the system architecture of the proposed driver. The whole driver system is consisted of driver block, FFE function, and light source. The driver block contains main driver and FFE driver. To simplify the system architecture, these 2 drivers utilize same structure with different driving current. To implement the FFE function, a proper delay is introduced to FFE driving signal, then combined with the main driving signal to enhance high-frequency components, which was depressed due to channel loss. A 5+5 RGB-LED array is used at the light source, while each color LED array equips with separate main driver and FFE driver. Input VLC data is under NRZ coding and driving red, green, and blue LEDs separately to guarantee the correct superposition in optical domain to form 4 different levels of current which produce the final PAM4 signal. The third part is design of RGB LED driver with FFE, which is also the main focus of this paper. So this is the schematic of RGB LED driver. The structure of this proposed RGB LED driver is based on traditional current regulator, which is one of constant current driving. The driving current is equal to the minus input voltage of amplifier dividing R1 and set as 60 mA for each branch. The amplifier used here is dynamic gate boosting amplifier, which is used to provide fast rising edge. DVLC is the input VLC signal, which is also used as enable signal for DGB amplifier. During the high-level stage of DVLC, the state of enable pulse in DGB amplifier is the same as DVLC, which is on. Thus, the gate capacitor of M6 to M10 is charged to driving voltage level. When it comes to low level, the enable pulse turns to off, and the charged gate is floating without discharging. DMH is the gate signal of M1 to M5 changes with DVLC synchronously but with different voltage level. At rising edge, ILED will immediately rise to high level as the already charged gate capacitor of M6 to M10, providing driving voltage to M1 to M5, which immensely decreases the rising time. At the falling edge, M14 helps to discharge in M13, while the M1 to M5 turn off promptly. These strategies will reduce falling time. The capacitor connecting between the gate and source of M6 to M10 will remove the overshoot of ILED at the high level. To implement the FFE function, FFE driving current derives from the main current, which be improperly inverted and delayed. After sent to corresponding FFE driver, the FFE signal combines with main signal at the end of LED serials to form final driving current ILED. The function of FFE is extending the bandwidth by increasing the peak of driving current at rising and falling edges, so that the loss of high-frequency components can be compensated, thus improving the quality of communication. The fourth part is the simulation results. The simulation verification consists of transient analysis and eye diagram measurement, which are performed in EDA tool Cadence. Since the current flowing through resistance connected in parallel with capacitance in LED model changes corresponding with LED light intensity, we utilize this resistance current to represent light signal in eye diagram analysis. These two figures are the measured waveforms. As shown in Figure A, I is the output driving current of the proposed driver, while DVLC is the input VLC data and represent in voltage. The maximum driving current is around 60 mA, while rising and falling edges changing corresponding with input VLC data. The transient waveforms of three different random 10 megabit per second NRZ data with combined final PAM4 driving current are shown in Figure B. The purple waveform is the combined PAM4 signal, while the red, green, blue waveforms are the driving current of the three LED arrays. This is the simulated eye diagrams. Figure A is the eye diagram of input signal for 10 megabit per second NRZ signal. Figure B is the eye diagram of output signal for 10 megabit per second NRZ signal and measured with the output driving current. The height of eye diagram for input voltage is 1.5 volts, while output current eye diagram height is around 55 mA. Since the transistor could not be totally turned off, the lowest current level is not equal to 0, and the total output eye height is therefore less than the highest current level, which is 60 mA. This is the simulated output eye diagrams for PAM4 signal. Figure A is the eye diagram of output signal for 10 megabit per second NRZ signal without FFE. Figure B is the eye diagram of output signal for 100 megabit per second NRZ signal without FFE. Figure C is the eye diagram of output signal for 10 megabit per second NRZ signal with FFE. And Figure D is the eye diagram of output signal for 100 megabit per second NRZ signal with FFE. The height of all four PAM4 eye diagrams are around 160 mA. By comparing figure A, B with figure C, D, the bandwidth has been extended obviously, which is reflected in the wider open eyes. The last part is the summary. In this paper, we proposed an RGB driver equipped with FFE to achieve high-speed PAM4 visible light communication. This driver is based on traditional current regulator structure with fast rising and falling edges. Both PAM4 scheme and FFE are practicable in this driver, and the FFE is contributed to increasing data rate, which is reflected in the wider opened eye of the eye diagram. Thanks to the HKUST Qualcomm Joint Innovation and Research Laboratory, also thanks to the Research and Development Program in key area of Guangdong Province for their support. This is the reference of this paper. That's all. Thank you all for listening, and here is the Q&A session.
Thank you, Mr. Chair. Good afternoon, everyone. My name is Han Qing Xiao. I'm from Nanjing University of Posts and Telecommunications. Currently, I'm doing some research on fountain coding and network coding. I'm honored to be here and share our recent research results with you. My topic is analysis and design of wireless distributed fountain codes with multiplicative network coding. My presentation includes the following 7 parts. Firstly, I will begin with the research background of this paper. As a novel forward error correction technology with redless property, fountain codes can adapt to the channel state and have strong flexibility on erasure channels. With well-designed degree distributions, fountain codes can approach the channel capacity of arbitrary erasure rates. Inspired by the good performance on erasure channels, more and more researchers are working to expand the application of fountain codes and to study their performance on wireless channels. On wireless networks, A decode and forward scheme based on exclusive OR network coding is usually performed at the relay nodes. However, this scheme increases the decoding complexity and brings extra processing delay, and the error propagation caused by incorrect decoding exists. The motivation of this paper is to solve the above problems. We propose a novel fountain coding scheme with multiplicative network coding for wireless distributed networks. A multiplicative network coding method is adopted instead of XOR network coding. Therefore, the processing complexity can be reduced greatly, and the error propagation caused by incorrect decoding can be avoided. Secondly, I will have a brief introduction of the system model for the proposed coding scheme. Consider the wireless distributed network model in Figure 1, where multiple source nodes transmit information to a destination node through a single relay node. The source relay and the relay destination channels are both wireless noisy channels. A simple time division multiplexing method is used to avoid interference. The duration of transmission can be divided into several time slots. The relay node performs network coding on the incoming symbols, which can save time slots and improve the throughput of the networks. Thirdly, I will demonstrate the proposed wireless distributed fountain codes with multiplicative network coding in this paper. Figure 2 gives the proposed fountain coding scheme for the wireless distributed network model, named Wireless Distributed Fountain Codes, or WDFC. Each source node performs LT encoding on K information bits independently. The relay node uses an amplify and forward method and performs network coding by multiplying two received symbols from both sources by two steps as follows. First, multiply the corresponding symbols of Y1 and Y2, which are received in different time slots alternately. The products form a new symbol stream Y. Second, amplify Y and then send the amplified signal Z tilde to the destination through wireless channel. Note that the product of two BPSK modulated symbols is equivalent to the XOR of two corresponding bits. It is indicated that multiplicative network coding is equivalent to XOR network coding. This is an important reason for performing multiplicative network coding instead of XOR network coding. Fourthly, I will introduce the asymptotic performance analysis of proposed codes. The degree distribution is an important parameter to determine the performance of fountain codes. The definitions of various degree distributions of source node, relay node, and destination node are shown here, such as input or output, node perspective, or edge perspective degree distributions. As demonstrated, the input degree distribution approaches to a Poisson distribution, and the overall degree distribution omega x observed at the destination node can be expressed as a composition of gamma x and phi x. The BP decoding algorithm for wireless channel is still applicable to the proposed WDFC. The log likelihood ratio of the channel is shown here. To analyze the performance asymptotically, we use semi-Gaussian approximation. Assuming that the LLRs of all input nodes are Gaussian, while the LLRs of all output nodes are not Gaussian, then we can derive the mean of LLR of an output node at the lth iteration as shown here. In practice, FD_mu can be obtained by calculating an empirical mean of U as follows. A. Calculate the LLR of the channel ZO. B. Let X be a symmetric Gaussian variable with mean mu. Sampling from X for d-1 times and getting d-1 samples Xi. C. Calculate the sample of U. D. Repeat B and C for Q times to obtain Q samples of U. Calculate the average value of Q samples as the empirical mean of U. Finally, the density evolution equation based on semi-Gaussian approximation can be derived as shown here. Based on the above density evolution analysis, we can optimize the degree distributions of WDFC. The optimization includes two steps. Step 1 is to optimize the overall output degree distribution omega x, with the objective to maximize the code rate and the main constraint of density evolution equation. We can optimize the overall edge perspective degree distribution lowercase omega x. Use the following linear program. Then, the overall node perspective degree distribution capital omega x can be determined as shown here. Step 2 is to optimize the output degree distributions of source and relay. Given the overall node perspective degree distribution omega x, we can use the least squares optimization problem with non-linear constraints to optimize the degree distributions gamma x and phi x as shown here. Based on the above analysis and optimization, some simulations are performed and some results will be shown. The simulation settings are shown in this table. With these parameters, we can use above two-step optimization to get the following degree distributions gamma x and phi x of source and relay, respectively. the overall input degree distribution lambda x and the overall output degree distribution omega x are shown in Figure 3 and Figure 4, respectively. Figure 3 shows that lambda x approaches to a Poisson distribution with average input degree of 12.66. Figure 4 compares omega x with gamma phi x. Simulation results show that the simulated distribution is consistent with the theoretical distribution. The analysis that the overall degree distribution omega x of the proposed WDFC can be expressed as a composition of gamma x and phi x is verified. Figure 5 depicts the BR performance of WDFC for different lengths of information bits with optimized degree distributions. Simulation results show that WDFC have good performance on wireless AWGN channels. The BER of WDFC decreases as the coding overhead epsilon increases, which verifies the theoretical analysis. In Figure 6, we further compare the BR performance of WDFC with SLT codes. It is showing that the BR performance of WDFC is superior to SLT codes with the same length of information bits. This is because the overall degree distribution of WDFC has been optimized, and the multiplicative network coding is adopted at the relay. Finally, I will have a summary about my research. In this paper, we have proposed a novel wireless distributed fountain coding scheme based on multiplicative network coding and have analyzed its decoding performance asymptotically using semi-Gaussian approximation. An optimization method for the design of degree distributions of WDFC has been further proposed. Simulation results have shown that WDFC has good performance on AWGN channels, and the theoretical analysis has been verified. In the future, we will study the network coding scheme for the relay with high-order modulation and the analysis and design of fountain coding in other networks, for example, cooperative relay networks. That's all of my presentation. Thank you. All questions are welcome.
Ladies and gentlemen, thank you very much for watching my video. I'm Jeff from Shenzhen Institute of Information Technology, and I'm very glad to have the opportunity to make this presentation. I'm going to talk about a fully integrated low-power wireless SoC, which is designed for Bluetooth low-energy application. I will show you the receiver design and how to solve the Fast-ICA offset cancellation and carrier frequency offset compensation problems. This is the outline of my presentation. First, I will show you the broad diagram of the proposed BLE SoC and the RF transceiver architecture. Next, the RF front-end with on-chip matching network will be discussed, and I will pay more time to discuss the DC offset cancellation and carrier frequency compensation problems and show you how to fix the problems. Finally, I will show you some of the measurement results. So, what is BLE? BLE stands for Bluetooth Low Energy and also called Bluetooth Smart. It is a lightweighted subset of Bluetooth standard and designed for those applications that can work for months or years with just one constant battery. It was first introduced as part of Bluetooth 4.0 code specification and then 4.1, 4.2, 5.0, 5.1. The typical applications are health monitoring devices like smartbands, smartwatches, beacons, smart house like smart lighting, and accessories of tablets or phones. The BLE protocol stack is divided into three main parts. The controller, which includes the physical layer and link layer. The host here, and the profiles for applications. Usually, the requirements of BLE-based devices are very low cost, means it should be very cheap, small form factor, and low battery life. There's also a very important functionality called OTA, that is, we can upgrade the application of firmware over the air. To meet these requirements, the SoC features should have embedded flash, low BOM cost, and low power consumption. This figure shows the building blocks of proposed SoC. It has on-chip PMU power management unit like DC-DC converter and low dropout regulators. And this is the BLE controller, including a 2.4 GHz RF transceiver and digital modem. Link layer, etc. We used ARM Cortex-0 M0 as the CPU of the SoC, and 256 kilobyte embedded flash is used to store the firmware for the stack and the application. The 32 kilobytes SRAM can be retained during low power mode. The SoC has a rich peripherals like high resolution timers, UART, SPI, PWM, multi-channel SAR ADC, and low power comparators. We also have high frequency and low frequency crystal or RC oscillators. Now let's have a look at the RF transceiver architecture. We employ a delayed modulation scheme for the transmitter to save power. Due to the mismatch between low frequency from the modulation and high frequency to the VCO, the calibration is needed for compensation. For the restriction path, a single conversion with low IF 1 or 2 MHz architecture is adopted. The down-converted RF signal will be digitalized by IQ 8-bit ADC and further demodulated by the digital modem here. The frequency synthesizer is a sigma delta fractional MP array and the VCO ramps 2 times LO around 4.8 GHz. This choice solved the pooling in the TS and it reduced LO self-missing, induced DC offset. Now, I would like to talk about more details about the RF front-end circuits. To make the SoC easy to use, first it is better to share the input and output into single pin. That is off-chip transmit or receive switch is not needed anymore. Second, on-chip matching network. It means that the antenna can directly connected to the RF I/O pin. The engineer without RF knowledge background can also use the SoC easily. For the receiver, we adopt a deflection mode, low noise amplifier for optimal power subjection, noise rejection, and spurious rejection. So it needs transformer to act as a balance for single-ended to differential conversion. We showed the switch as 1 to ground. Then the transmission path here is a switch and switch off. The total passive device here performs the balance and the implant matching network for the LNA here. Single-ended to differential. This is for differential. Single-ended for differential. This is the matching network. Also add a balance to convert the single end to differential here. This is differential low noise amplifier. For the transmitter, we can show the two switches as true to ground and switch off all the distribution path. Then, the power amplifier output here can go through the matching network here, matching network to the antenna here, directly to the antenna. Now, I would like to talk about the DC offset problems. DC offset is an offsetting of a signal from 0. That means there's a direct current component in the signal. This is differential signal here. I path differential signal here. This is due to the DC offset here. The mismatch between difflection path with general DC offset, another scheme called LO leakage self-missing, also generates a variable DC level that appears as interference after down conversion in the receiver. This picture shows self-missing due to the finite isolation typical of silicon-based IC between the LO and RF ports of a emitter. For such emitters, pole-to-pole isolation is limited, since the LO is typically strong signal in order to provide sufficient drive for the emitter switch core. The LO can lead with sufficient high amplitude through this unintended path back to the full front-end low noise amplifier. There, the LO signal can reflect off the LNA back to the input of emitter and mix with itself, thereby generating a steady DC level that's called LO self-missing. The DC offset will cause several problems. The large DC offset will cause the receiver to reduce the amplitude of incoming received signal to avoid clipping and distortion. And the variable DC offset will cause the unreliability in the recovery of the received data. To avoid saturating the ADC or deteriorating the RF sensitivity performance. DC offset cancellation, also called DCOC, is needed, especially when the gain of the RF analog baseband is large, 30 dB or above. This picture shows the block diagram of the proposed DCOC solution. I path and Q path DC offset is cancelled individually. The analog comparator here compares the differential output of I path or Q path and generates 0 or 1. The digital counter accumulated the number of 0 and 1 for several microseconds, and then control the 8-bit DAC to cancel the DC offset at the endpoint of RF analog baseband. To keep the number of the comparator output 0, 1, 0 or 1 are equals to each other. Thus, the DC offset residue is close to 0. According to the BLE specification, there is only 8 micropreambles for automatic gain control. DCOC should be settled in such a short time. How to solve this problem? A lookup table with different DAC codes related to the different RS gain is used to meet such stringent requirements. The codes in the table will be updated every time when the SoC wakes up from deep sleep mode and stored in the retention RAM if needed. See, the carrier frequency offset arises due to 2 reasons. The first one is frequency mismatch between the TS and RS oscillators. No two devices are the same, and there's always some difference between the manufacturer's nominal specification and the real frequency of that device. Moreover, this actual frequency keeps changing slightly, with temperature, pressure, age, and some other factors. The second one is Doppler effect. A moving TS, RS, or any kind of movement around the channel creates a Doppler shift that creates a carrier frequency offset as well. So, what is the problem carrier frequency offset will introduce? This picture shows the problem. Even though the RS signal is within the passband of analog filter, here analog filter, this is the RS signal bandwidth, is within the analog pre-filters and suffers no distortion. However, to maximize the SNR, the RS signal must be passed through the digital match filter here. This is the match filter. There's possible that much of the RS signal bandwidth does not sufficient overlap with the match filter due to the CFO here. This is CFO here. If applied, it will remove a significant portion of the incoming signal energy, thus deteriorating the RS performance. So we need to solve the CFO problems. This picture shows the digital modem with the CFO compensations. The carrier frequency offset is estimated here and cost compensated in the digital down conversion here, and the final compensation is used in here. This is JTFA digital modem also have some other functionalities such as RSSI, ISSI calculation this used to IGSO and auto gain control to control the RF and analog baseband gain of the receiver. And this is the channel select filter, digital channel select filter, also called the match filter here. Now I will show you the SoC implementation and measurement results. The SoC is fabricated in 55 nano RF CMOS technology and the diphoto is shown here. The radio, modem, link controller, CPU and memories, embedded flash, SRAM are all integrated on chip, along with a power management unit, clock management unit, and oscillators, and digital and analog peripherals here. This picture shows the input matching network less than minus 17 dB in the distribution path, and this figure shows the output matching less than minus 13.5 dB in the transmission band. These two pictures show the DCOC and AGC setting process respectively. This is show the DCOC setting process. It is less than 3 microseconds, and this shows the AGC low gain to high gain, and the setting time is less than 3 microseconds. This figure shows the PR performance of the RF sensitivity. The RF sensitivity of about minus 19.5 dBm is achieved without carrier frequency offset. The CFO compensation in digital modem helps to extend the CFO tolerance from plus and minus 100 kHz to plus and minus 250 kHz. The sensitivity is only 2 dB degradation. Finally, let me show you the reference design based on the proposed SoC. This is the reference circuit. It has very few discrete components. Only one inductors, several capacitors, 2 crystals. And this is the module, RF module based on this SoC. And this shows the smart band design based on this SoC. Let's now make a conclusion for now. A few integrated BLE SoC with both DCOC and CF compensation in 55 nano RF CMOS process was presented. The DCOC setting time is less than 3 microseconds due to the proposed DCOC solution. The CF tolerance is extended to plus and minus 250 kHz with only 2 dB sensitivity degradation. That's all. Thank you very much.
Recognition of TT&C signals of satellite based on JTFA and Fast-ICA algorithm. A blind subcarrier recognition algorithm of JTFA communication is proposed based on JTFA joint time frequency analysis and Fast-ICA algorithm. In this method, we use time-frequency analysis technology to extract the features of the satellite signals and the Fast-ICA to enhance signal-noise ratio effectively as one of the best tools to analyze the non-stationary signals. It shows information in the giant time frequency domain and makes us know about the change of the frequency along with the timing clearly. Before the time frequency analysis of the satellite signal, the premise is to remove noise based on analyzing Fast-ICA algorithm deeply. This paper exposes a new method to adopt it in the recognition of the TT&C signals of satellite simulation results shows its better performance and efficiency in the mixed TT&C signals of satellite recognition, proving its good convergence and robustness. The characteristic of the least algorithm is that we need not any prime information. Satellite monitoring for a special machine mechanics and advantages plays an important role in modern military information wars. Now, information scout of military monitoring communications. S-band monitoring system I used most, so an outstanding issue is to extract multiple sub-carriers from a single monitoring frequency band for the identification of satellite monitoring sub-carrier signals with mutual independency and known bandwidths and the number of signals, but indivisible spectral bands. Manual detection methods are most used presently. This method has fast detection rate, high cost, and complex operations, so it cannot meet the requirements of information scout in the EAI environment and the information wars. The time frequency analysis technique of signal processing is a powerful tool. It is used to analyze non-stationary signals. The basic idea of time frequency analysis is to design a joint function of time and frequency and use it to describe simultaneously the energy density or intensity of the signal at different times and frequencies. The number is called time-frequency distribution, using time-frequency distribution to analyze the signal can give the instantaneous of each moment frequency and its amplitude, and can be used for time-frequency metering and time-varying signal research. Independent component analysis is a popular signal processing technique that is introduced in recent years. Independent component analysis is recover the source signal from observation signals without the instant mixing parameters with only a little statistic information, mutual dependency, and Gauss distribution. In the field of communication signal detection, this method can effectively separate signals that is overlapped in the spectrum and then analyze the separated signals one by one so that the spectrally overlapped signals can be effectively analyzed. This paper, Independent Component Analysis, algorithms based on neutron-trophy maximization is used in research of satellite monitoring signal identification algorithms. The study results may have enormous potential in communication and military applications. Independent component analysis. Let x1 is true and xn be an n-dimensional observation signal and beta m mutually independent source signals that generate the observation signal and the observation signal x, each generated by the source signal s by linear combination, which can be expressed by the following expression: 2. The independent component analysis (ICA) always is when the mixed matrix A and source signal S are known only by the assumption and that the source signals are mutually independent. So found the linear transformation metric W, also called demixed metric, to transform X by linear transformation to get an output vector Y that is also close to the source signal as possible, as estimation of the independent component S, named after independent component analysis was proposed. Many efforts have been made to this, and practical application in many fields, many areas have been presented. The algorithm used here is the Fast-ICA algorithm based on the maximization of new gentry. This algorithm is be introduced in detail in the following sections. Derivation of the algorithm. According the central limit of yi is more constant, Si when yi ds I, the Constellation will reach a local minimum. It is obvious that at least that point, there would be only one non-zero element in each row of M. The problem is equivalent to find the doublet mix. Before we analyze interstellatory modeling, single recognition of the following steps are made. Before processing the preprocessing to zero signals is needed, including centralizing and whitening. Centralizing is to subtract the mean after all to the observation vector x from it to make x a zero mean vector. The meaning vectoring whitening is to make a transformation Q on the observation vector. After transformation, the relationship between V and S is because the independent components have united variances and B is all of them symmetric. As also based on the method of neutral. It can be seen from the simulation results of the about maintenance. The independent analysis method based on the static independency of the signal sources not only can overcome the limitation of single complexity and inability to identify signals with pairs of conventional single separation methods that are based on single parameters, but also can make great improvement to identification. The separation performance depends on the total number of sampling points and the different parameters between different singles. Generally speaking, the more of the single points, the better of the separating results. The greater the difference between singles, the better of the separating result. In the case of very close parameters, if the singles cannot be properly separated with a certain number of the sampling points, but increasing the sample points, but the single may be properly separated. Generally speaking, the above simulation results powerfully proves that independent component size is indeed a better method for satellite modeling, single separation and identification.
I am a lecturer from Shenzhen Institute of Information Technology. It's my great pleasure to be here to give the presentation. I would like to share with you some of our research process on holography. The title of my presentation is Kinoform generated combined with the error diffusion method and the dynamic range phase. My presentation is structured in the following way. I will begin with an introduction to show the motivation of our research. Then, I will move on the proposed synthetic method of the Kinoform. After that, the simulation results are given. And finally, I will sum up the investigation. Okay, let's start by a bit of background. Firstly, we will introduce the advantages of the Kinoform. As we know, Kinoform is a phase-only hologram, which regards the amplitude of interface light as a constant. Compared with amplitude-type holograms, the Kinoform has several advantages. Firstly, it can be displayed with a face-only device, and result in higher optical diffraction efficiency. And thirdly, it can be rejection of the conjugate image and the real zero-order image. However, removing the amplitude component will result in substantial degradation on the reconstructed image. To solve the problem, some optimization approaches are presented, such as the Joubert-Sexton algorithm, the bidirectional error diffusion algorithm and the integrated iterative Fresnel transform method. Inspired by the previous works, in this paper we a computer-generated Kinoform combined with error diffusion and the dynamic random phase is presented. Then let's move on to the proposed synthetic method. The complex amplitude of the Fresnel hologram is generated from the object waves emitted from each point on an object in the equation. And then the phase-only hologram can be obtained from the complex amplitude of the hologram. After that, the error can be given by setting the magnitude to unity. To overcome the problem, the Florida-Steinberger error diffusion technology is employed to compensate the error. Figure 1 shows the error diffusion proposed more intuitively. The errors generated on the order rows are diffused to the neighborhood pixels that have not been visited according to the following equations, from which we know the pixels on the order rows are scanned from left to right. According to the reference, A1 to A4 are set as this equation. And after that, the sequential Kinoforms can be obtained by setting the phase factor randomly assigned from 0 to 2 pi in each calculation. Then the intention information of each reconstructed image from sequential Kinoforms is superiorized and normalized as the intention information of the final reproduced image. The key point of our proposed is as following. The first one is the error diffusion method is employed, and then the dynamic random phase method is combined with the first one. Thirdly, we will introduce the simulation result. The numeric reconstructed image is obtained by using the convolution method. Figure 2c shows the image reconstructed from the original Kinoform. The severe attenuation appears in the reconstructed image, which is caused by removing the magnitude information of the hologram. Figure 3 shows the image reconstructed from the error diffusion Kinoform described in part 2, from which we can see the brightness of the reconstructed image is increased. However, the distortion also appears in the image. Then, based on the error diffusion method, the red phase factor is added to achieve the Kinoform. Figure 4 shows the image reconstructed from the Kinoform generated when the red phase is added only. The reconstructed image in in this picture is obtained from the Kinoform generated combined with the error diffusion and the random phase factor. The results show that the presentation quality of the reconstructed image is improved significantly from the Kinoform generated combined with error diffusion method and the random phase factor. Figure 5 shows the image reconstructed from the image used the dynamic random phase method with the 5th, 10th, and 20th iteration numbers. In the B, we can see the image reconstructed from the Kinoform generated combined with error diffusion method and the dynamic random phase with the same iteration numbers. And the pink single to noise ratio PSNR is used to evaluate the quality of the reconstruction image. The results are shown in Table 1, from which we can see that the reconstructed results from the Kinoform generated combined with the error diffusion and the dynamic random phase are superior to that Kinoform generated with the dynamic random phase only. Then we will do a summary. In conclusion, a computer-generated Kinoform combined with error diffusion and the dynamic random phase is presented. The error diffusion approach is used to compensate the error caused by removing the magnitude information of the phase-only hologram. And sequential Kinoforms are obtained by adding dynamic phase factor into the object domain to reduce the speckle noise. The result demonstrated that the representation quality of the reconstructed image can be removed compared with that obtained from the original Kinoform. We can see the error diffusion approach is used to compensate the error caused by removing the magnitude information. And sequential Kinoforms are obtained by adding dynamic phase factor into the object domain to reduce the speckle noise. Then, the acknowledgement. I'd like to thank to the members of our group at 冥想馆 林荣夏、金平范 and 建王. And besides, I'd like to thank to the financial support of the of our project. The first project is the scientific and technological projects of Shenzhen. The number is JCYJ 2019-08-08-09-3001-772. And the other project is the Guangdong Province Higher Vocational College and Schools Peer River Corner Fund Scheme. And the third project is the project of the Shenzhen Science and the Technology Innovation Committee. And then we are supported by the research platform and the projects of Department of Education of Guangdong Province, and engineering applications of artificial intelligence technology laboratory, and the Provincial Natural Science Foundation of Guangdong. The number is 20178030313337. Thank you for your attention.
Hello everyone, I'm Yiru Wang from Hong Kong University of Science and Technology. Thank you for coming to my talk. I'm going to present performance analysis and evaluation of outdoor visible light communication reception. This is the outline of my presentation. I will start with the introduction of this work, and then the outdoor experiments and performance evaluation will be presented, including the experiments and evaluation on VLC system and the strong sunlight with different types of receivers, namely the image sensor and the photodetector. Finally, I will summarize this work and make a conclusion. Let's move on to the first part. I will introduce VLC and its different types of receivers and VLC in outdoor scenarios. Visible light communication transmits signals via visible light beam. As shown in the figure, it uses black light bulb for 0 and white for 1. It can transmit data at a high speed and provide illumination at the same time. VLC systems have multiple advantages. Compared with conventional RF systems, VLC generates no RF radiation and electromagnetic interference, making it suitable for application in sensitive environments, such as hospital and airplane. Besides, the line of sight characteristics of visible light beam make VLC more secure in comparison to other indoor communication, such as Wi-Fi, because visible light cannot penetrate through walls. VLC signals in different rooms are independent and private. Furthermore, it has a licensed lag spectrum, meaning that it can be used anywhere, anytime. And the enormous bandwidth offers the possibility for high data rate communication. VLC technology is also compliant with existing infrastructures, meaning that it can take advantage of existing hardware, such as LED lightings, to implement a practical system, which requires very low cost. VLC has two types of receivers, including image sensor and photodetector as shown in the figure. VLC systems can provide short range of 1 to 2 meter navigation with image sensor-based receiver and high data rate communication of up to 5 meter range with PD-based receiver. Thanks to the properties of LEDs and these two types of receivers, VLC technology is very competitive in providing multiple services, including indoor positioning, intelligent illumination, smart display, and underwater communication. Compared with PDs, image sensors are less expensive and more widely equipped on mobile devices. A smartphone-based VLC system consists of an LED-based transmitter and a smartphone-based receiver as illustrated in the figure. The LED-based transmitter is controlled by a VLC-enabled LED driver to transmit optical waveforms. The bright bars correspond to the transmitted data 1, and the dark bars correspond to the transmitted data 0 as shown in figure B. Then, at the receiver side, the CMOS image sensor on the smartphone captures the pixel from top to bottom and records the rolling shutter patterns. Thus, as long as the data rate of the LED is modulated higher than the frame rate of the smartphone, the transmitter signals will be recorded as the rolling shutter patterns on the image sensor. After adding an error check sequence, the decoded binary sequences will consist a data frame with unique ID, and then the ID is mapped into a uniform resource identifier database and read by the application software. In a PD-based VLC system, the PD-based receiver converts the optical power to electrical current. Compared with an image sensor-based VLC system, a PD-based system can achieve higher data rate. The detection area of PDs are very small. Therefore, PD-based VLC systems require precise alignment between LED and PD for signal detection. VLC can also be applied to outdoor scenarios. Existing researches on outdoor VLC systems mainly focus on vehicle-to-vehicle communication and positioning using head and tail lights, and vehicle-to-infrastructure communication and positioning using LED traffic lights. With the high-speed development of the 5th generation, the long-term goals of smart cities have attracted much attention from academia and industry. Based on well-developed roads and highways, smart street lightings can provide efficient support for the establishment of smart cities. If we enable VLC technology on mobile devices and integrate it with smart street lightings as shown in the figure, the advantages of VLC technology and the wide distribution of street lightings can intensely contribute to diverse public services. However, outdoor applications face more challenges, including the strong ambient light disturbance, optical defects in lens, leading to the indistinction of the captured images at the receiver side. Addressing and solving these challenges enables VLC technology in outdoor application and fully exploits the advantages of VLC. Then let's move on to the second part, the outdoor experiments and performance evaluation of VLC systems. We conduct outdoor experiments on image sensor-based VLC system and PD-based VLC system to evaluate their availability in outdoor environments. For image sensor-based VLC systems, we measure the hit rates and analyze the captured rolling shutter patterns by image processing methods. For the PD-based VLC system, we evaluate the performance with an oscilloscope and add a DC offset to filter the high-intensity ambient sunlight. We evaluate the performances of the image sensor-based outdoor VLC system in two cases. In case 1, we place the system under sunlight intensity of 67,800 luxes. In case 2, the light intensity is 6,800 luxes. The power of the LED panel is 18 volt. The experiment setup consists of an LED with a yellow pole and a smartphone with an image sensor. The height of the LED is set as 2 meters. The experiment's results of case 1 are given in the table. When the distance between the LED and the camera is longer than 0.5, the hit rate is lower than 40%. When the distance is about 0.3 meters, we can obtain the maximum hit rate of 55%. However, the transmission distance of 0.3 meters is much shorter than the required minimum detection distance for outdoor communication and positioning. The very low hit rate is due to the indistinct rolling shutter patterns captured by the camera as shown in the figure. Then, we perform image processing algorithms to analyze the performance. Firstly, we extract a pixel with VLC pocket as shown in figure A. Then, second-order polynomial is applied to reduce the extinction ratio fluctuation. Subsequently, quick adaptive thresholding is implemented to identify data logic, as shown in figure B. It can be obviously observed from the figure that the rolling shutter patterns cannot be decoded correctly. Then, the experiment's result and the weak sunlight are given in the table. When the distance is between 0.8 meters and 0.3 meters, the hit rate is higher than 90%. The hit rates of the VLC transmission under weak sunlight are much higher than these under strong sunlight. Besides, the rolling shutter patterns captured are much more distinct and clear as shown in the figure. When we use smartphone to communicate, the normal height of the smartphone in our hands is between 1.1 meters and 1.4 meters. Therefore, when the height of the LED is set as 2 meters, the normal distance between the camera and the LED is between 0.6 meters and 0.9 meters. Based on our measurement under strong sunlight, communication set with the distance in above bands cannot successfully receive transmitted signals. Only the communication site under weak sunlight can decode rolling shutter patterns. Then we perform similar image processing algorithms to analyze the performances, namely extracting the pixel with VLC pocket as shown in figure A, performing SOP and quick adaptive thresholding as shown in figure B. From the results, we can find that the patterns can be successfully decoded. To evaluate the performance of PD-based VLC systems under strong sunlight, we set a PD as receiver and use an oscilloscope to observe the signals as shown in the figure. Since the PD is remarkably sensitive to receiving angles, we use a 1 volt bulb to assure the alignment between the PD and the LED. The sunlight intensity is the same as in case 1. The very high sunlight covers the light transmitted by the LED, and the signal received by the PD is like noise. Therefore, the PD cannot recover the transmitted signals. To filter the high-intensity ambient sunlight, a DC offset is applied at the PD. Then the pattern received by the PD is with very slight flash, as shown in the figure. The maximum detection distance of the PD-based VLC system is about 0.4 meters. compared with an image sensor-based VLC system under strong sunlight. A PD-based system can achieve much longer transmission distance with a lower power transmitter. In this part, I will summarize this work and make a conclusion. In this paper, we evaluate the performances of outdoor VLC systems with two types of receivers, including image sensors and PDs. From the measured hit rates and captured rolling shutter patterns, we can find that when the image sensor-based VLC system is under strong sunlight, the communication distance is much shorter than the required minimum detection distance. Compared with image sensor-based systems, PD-based systems with DC offset can successfully identify and decode transmitted signals at a much longer distance of the same sunlight intensity. However, due to the strict requirement of the alignment between the PD and LED, existing PD-based VLC systems cannot achieve angular diversity and provide robust and practical communication and position services for mobile devices in both outdoor and indoor environments. Here gives the references. Finally, I would like to thank you for your attention.
Hi everyone! The topic I talk today is simulation study of channel number of cochlear implant in quiet state. I will talk from these 5 parts. First of all, introduction. This is a picture of cochlear implant. Cochlear implant is a hearing recovery device. It directly stimulates auditory nerve fibers of the severe hearing impaired patients with a weak current, excites auditory nerve fibers to mimic the physiological functions of the peripheral auditory system, generates a neural release pattern similar to normal persons, and thereby partially restores the hearing of deaf patients, and present the vast majority of cochlear implant products adopt speech processing strategies based on temporal envelopes, which can effectively recognize non-tonal language. However, these strategies do not encode the tonal information of speech, making it difficult for users speaking Chinese to perceive tonal language. In order to enhance the tonal information of the cochlear implant, researchers studied the effect of channel number on tongue recognition on Mandarin Chinese. Some researchers found that in quiet state, when the total number of channels of the cochlear implant was increased from 1 or 2 to 4, the tongue recognition rate was not significantly improved. However, Xu used Chinese single syllable words of the same duration to conduct simulation experiments in quiet state. Xu found that when the total number of channels was increased from 1 to 4, the tongue recognition rate increased significantly, and that the recognition rate of 3 or 4 channels was significantly higher than that of 1 channel. This phenomenon contradicts Fu's previous results. In addition, in the experiments of Xu, when the number of channels continued to increase from 4, the tongue recognition rate of 6, 8, 10, and 12 channels no longer increased significantly, but reached a platform. Besides, the recognition rates of these channels were all significantly higher than the recalculation rate of only one channel. In addition, the recalculation rates of 8 and 12 channels were significantly higher than those of 2 channels. It is worth noting that the variable in the above studies is the total number of channels. The current paper changed the number of channels in the low, medium, and high frequency bands of the cochlear implant, respectively, and tried to explore the impact of channel number in different frequency bands on tongue recognition of Mandarin Chinese. For the methods and the materials, first of all, I will talk about the theoretical methods. A frequency range FL to FH is divided into n channels by a multiplier factor x. Then equation 1 should be satisfied. Among the n channels, the higher cutoff frequency of the ith channel FIH can be calculated by equation 2. The lower cutoff frequency of channel I plus 1 equals the high cutoff frequency of channel I. Thus, frequency rate of each channel and the multiplication factor x can be obtained from equations 1 and 2. In this experiment, the frequency range 60 to 8000 Hz was divided into 3 parts, including the low frequency band 60 to 1000 Hz, the medium frequency band 1000 to 4000 Hz, and the high frequency band 4000 to 8000 Hz. So, part 1. I will change number of channels in the low frequency band, keeping 2 channels for the medium frequency band and 1 channel for the high frequency band unchanged. Increase the number of channels in the low frequency band from 2 to 32 to explore the impact of the number of low frequency band on tongue recognition rate. This situation is represented as no case. The total number of channels in this case is from 5 to 35. That is 5, 7, 11, 19, and 35. Part 2. I will change number of channels in the medium frequency band, keeping 2 channels for the low frequency band and 1 channel for the high frequency band unchanged. Increase the number of channels in the medium frequency band from 2 to 32 to explore the impact of the number of the medium frequency band on tongue recognition rate. This situation is represented as medium case. The total number of channels in this case is from 5 to 35. Part 3. I will change the number of channels in the high frequency band, keeping 2 channels for the low frequency band and 2 channels for the medium frequency band unchanged. Increase the number of channels in the high frequency band from 1 to 32 to explore the impact of the number of the high frequency band on tongue recognition rate. This situation is represented as high case. The total number of channels in this case is from 5 to 36. Next, for the speech processing strategy, this paper proposed an improved continuous interleaved sampling strategy named CIS based on the channels designed before. The voice was first framed, ended with a Hamming window, and passed through an FIR linear phase bandpass filter bank. The channels of filter bank were designed by the method introduced above. Then, full-wave rectification and low-pass filtering was applied on a single of each channel to obtain an envelope. The envelope was modulated with the band-limited noise of the corresponding channel To avoid signal leakage, the modulated signal was bandpass filtered again. The root mean square equalization was performed. Then, the signals of each channel were summed to obtain a simulated composite signal for each frame. Finally, the signals of each frame were superimposed and averaged to obtain a speech signal. For the material, this experiment used a phonetic vocabulary of Mandarin Chinese recorded by Fu, with a total of more than 1,500 female pronunciation words. The voice was processed by man's lab software, passed through the sound card, and played through HD 650 headphones. The subjects were tested in double-layer soundproof rooms. For the subjects, 12 college students aged between 19 and 23 years participated in the experiments. All the listeners were native Mandarin speakers with normal hearing and octave frequencies between 125 and 80,000 Hz in both ears. Each listener was trained for at least 1 hour until the results became stable. And for the test content, we will record total tongue recognition rate, 1 tongue recognition rate, T1, 2 tongue recognition rate, T2, 3 tongue recognition rate, T3, and 4 tongue recognition rate, T4. So now we come to the results. First, the result of changing number of channels in no frequency band. When the number of no frequency channels was 2, 4, 8, 16, and 32. The total number of channels over the entire frequency range was 5, 7, 11, 19, and 35, respectively, increasing the number of no frequency channels. Total T1, T3, and T4 all rose slowly, but there was no significant difference. T2 showed fluctuations. Each tongue recognition rate was ranked from high to low as first T3, then T4, then T2, and the last one T1. Total remained at 63% to 70%, which is consistent with previous experimental results. In addition, LSD pairwise comparison found that for T4, recognition rate for the 2 no frequency channels was significantly lower than that for the 32 no frequency channels. For the results of changing number of channels in medium frequency band, when the number of medium frequency channels was 2, 4, 8, 16, and 32. The total number of channels over the entire frequency range was 5, 7, 11, 19, and 35 respectively, increasing the number of medium frequency channels. Total T1 and T3 all rose slowly, but there was no significant difference. T2 and T4 fluctuated. Each tongue recognition rate was ranked from high to low as first T3, and then T4, and then T2, and the last one T1. The overall tongue recognition rate was maintained at 60% to 70%, which is consistent with the previous experimental results. And for the results of changing number of channels in high frequency band, when the number of high frequency channels was 1, 2, 4, 8, 16, and 32. The total number of channels over the entire fringe was 5, 6, 8, 12, 20, and 36, respectively. Increasing the number of high-frequency channels, total T1, T2, T3, and T4, rose slowly or fluctuated. Each tone recognition rate was ranked from high to low as T3, then T4, then T2, then T1. Total remained at 60% to 72%, which is consistent with the previous experimental results. For T3, the recognition rate for 8 high-frequency channels was significantly lower than that for 32 high-frequency channels. For T1, the recognition rate for one high-frequency channel was significantly lower than for 16 high-frequency channels. So, let's talk about the discussion. When the number of channels in the low, medium, and high frequency bands was changed respectively, total for the three cases was maintained between 60% to 72%, which is consistent with previous studies. 罗新 and Fu Jianjie used the noise band carrier to carry out simulation experiments and found that the 2-channel and 4-channel tone recognition rates were about 62 in quiet state. The research of Fu found that when the number of channels was 1 to 4, the score of Mandarin Chinese tone recognition was stable at about 60% to 80% in acquired states. For the low, medium, and high cases, the recognition rates of each tone had a common phenomenon. T3 was the highest, followed by the T4 and T2 in sequence, and the lowest was T1. This indicates that T3, tone 3, and tone 4 are easier to recognize, and the tone 1 and tone 2 are not easy to recognize. This is consistent with previous results. The reason why tone 3 and tone 4 are easier to identify may be related to duration. Tone 3 has the longest length and tone 4 has the shortest length. However, the contribution of the duration Q might be small. When the number of channels in the low, medium, and high frequency bands was increased respectively, the tone recognition rates fluctuated or rose slowly. However, there was no significant difference. This is similar with previous studies. Lo and Fu used the noise band carrier to carry out simulation experiments and found that when the total number of channels increased from 2 to 4, Mandarin Chinese tone recognition in quiet state was not affected by the total number of channels in the spectrum. Fu had similar conclusions. This explains from another point of view that for the CIS simulation, 4 to 6 channels are enough to achieve a good recognition rate of Mandarin Chinese tones in quiet state. However, LSD pairwise comparison found that for T4 in a low frequency band, 2-channel tone recognition rate was significantly lower than a 32-channel tone recognition rate. It may be related to the easier identification of tone 4. The curve of tone 4 changes from high to low significantly with the shortest length. Another reason is that when the number of channels is 32, the tone recognition rate is very similar to that of the original sound. In addition, for Tone 1 recognition in a high-frequency band, LSD pairwise comparison found that recognition rate of one channel was significantly lower than that of 16 channels. Moreover, non-parametric tests found that type of channel had no significant effect on T3. Variance analysis and a non-parametric test found that the type of channel had no significant effect on total T1, T2, or T4. However, LSD pairwise comparison found that 3 significant difference. For the concluding, in quiet states, a number of channels has a certain effect on the tone recognition rate of Mandarin Chinese. As the number of channels increases, the tone recognition rate rises. For the recognition of tone 3, the channel type, low, medium, and high, has a significant impact. However, channel type has no significant impact on other tone recognition, except for a few local significant differences found by LSD pairwise comparison. Thanks very much.
Attention for this is simulation system of cochlear implant. My name is Yu Seng Chen. Introduction. At present, there are 3 major cochlear manufacturers in Australia, Austria, and the United States. In recent years, acoustic research institutions and research universities in China have carried out research work related to cochlear implant. A company in Hangzhou has also developed a domestic cochlear implant. The clinical performance of related products are being tested and evaluated, and some products have been used in clinical. With the development of recent decades, the performance of cochlear implant have been greatly improved, but the recognition rate is still low in practical application. Scholars have shown that for 50% sentence recognition rate, the signal-to-noise ratio required by normal people is about -10 dB, while the signal-to-noise ratio required by cochlear users is between 5 and 50 dB. Therefore, under the noise of normal living environment, the speech recognition rate of cochlear implant users is still low. The factors that affect the low speech recognition rate of cochlear implant include the interference of noise environment and the mismatch of application scenarios, which will greatly reduce the performance of cochlear implant. Improving the speech recognition rate of cochlear implant in noise environment is still one of the research focus in this field. At present, the research of cochlear implant mainly focuses on the following aspects. First, improving speech processing algorithms, such as extracting and transmitting more effective information, extracting the fundamental frequency and change information for the unique tone feature of Chinese. Second, the improvement of device and electrode. For example, the high-resolution strategy of cochlear implant can obtain the fine structure of the signal and improve the stimulate rate of the electrode to transmit more abundant information. At present, more release focus on the enhancement of the front-end signal-to-noise ratio of the cochlear implant, virtual channel technology, and the optical cochlear. This paper designs a portable cochlear implant voice simulation and speech training system. The hardware and software system is a simulated test performance, which has low price, simple test mode, large customer base, and potential market value. Structure and functions of cochlear implant. For normal people, the outer ear and middle ear are mechanic transmission device of external sound signal. Functional electrical simulation can directly simulate the residual audio nerve in cochlear. As an alternative device, the cochlear replaces some functions of the ear. Hardware circuit. This system includes two parts, hardware and software. The hardware consists of two ARM processors to form a dual channel acquisition system, which can be started at the same time by pressing the key, which is helpful to improve the portability and real time of signal acquisition. At the same time, the two microphones are placed at a adjustable distance. The two ARM processors connect and save the information of the two microphones at the same time. An accurate record the spatial orientation information of the two microphones, which can be used for the design of the microphone array algorithm. Control and processor model. Because the system is to collect dual channel signal and accurately record the difference between signals, the system uses two ARM processors to collect and process the same time. STM32 chip is selected for this system. In order to accurately and synchronous start signal acquisition, the system uses a key switch to connect two STM32 pins at the same time, which can simultaneously start signal acquisition to reduce the time delay of two signal acquisition. Software GUI. The sound is collected by microphone, filtered and amplified by a pre-processing circuit, and finally collected to a computer through the development of a voice simulation software GUI on the computer. After selecting and setting parameters on the GUI. The specific voice processing strategy is called and collect voice signal is processing by the voice processing algorithm. Then the corresponding analog voice in the synthesis algorithm is synthesized, and finally the synthetic voice is placed through the speaker. The sound played by the speaker is based on the Cochlear speech processing strategy and actual parameters. Therefore, the synthesized sound signal is simulated the hearing of the Cochlear users under the simulation of electrode. We use MATLAB to develop this software GUI. Conclusion: there are a large number of hearing impaired patients in Shenzhen and other mega cities, which have great potential demand for cochlear implant, especially for obtaining high-quality hearing perception in noise environment. Improving speech recognition rate in noise environment is one of the final destinations for the improvement of cochlear implant. This paper has accumulated technology in the early stage and developed a sound simulation and deafness simulation training system for cochlear implant. The system has not only technology innovation but also high social and commercial value. It can not only simulate signal and synthesize speech, but also extract parameter and train us of the cochlear implant. Is an auxiliary device or deaf patients wearing cochlear implant. Thank you.
Dear judges, I'm going to introduce Engineering PEC Enterprise Energy Management System Service. The author of this paper is Feng Yuyang. He's from Shenzhen Taoyuan Energy Technological Company in Shenzhen from China. The present paper can be summarized as Energy PEC Enterprise provides enterprises with the function of energy visualization, Kanban. Using can customize their energy using devices by checking the box on the home page and see the change of energy consumption of devices in real time, so as to achieve the overall energy using macro data management of Shenzhen Technological. And the keywords of this paper is that virtualization, energy using, and data management. From this paper, we build a virtualization system named Kanban, and we use the system to see the change of energy consumption of devices in real time, so as to achieve to overall the energy using to microdata management of Shenzhen Technological. Energy PEC Enterprise provides enterprise with the function of energy resolution. Users can use this system to customize their energy using devices by checking the box on the home page. The following is introduction. Demand management is mainly used for measure the management of transformer side demand, helping user to carry out base capacity management and demand management charging. Users can choose whether to use demand charts or not based on date, rather than the current basic capacity fee plus actual consumption. The goal of this function model is to help users decide which charging method will reduce their actual electricity bill. From Figure 1 is multi-source data aggregation. The most important part of Figure 1 is scenarios, and there are three parts below: structured, unstructured, industrial device state, global data models, and feeder extraction interface. All about this is to data source and entities. The following is system design. Users can use in statistical analyze model calendar, map function, energy consumption requirement energy consumption solutions in single month, daily calendar display, energy consumption wheel in the form of micro energy consumption. The solution of the whole month. Click on the figure in a single calendar can view the details of the date to the day and can progress the date contrast of different calendar day. From Figure 2, data flow chart. Users can directly view the historical energy consumption date of the requirement in the statistical analyze model, including the historical date of the requirement, such as electric energy flow purchase temperature, and can automatically calendar the maximum, minimum, and average value of the date within a certain time range. The most important things about this video is not the fast or fluently. You can use it with some difficult, some is okay. User can use in statistical analyze model calendar. And I use this video to statistical analyze model calendar map, energy consumption, equipment energy consumption, can view the detail of data display, and can progress the date contrast of different calendar day. The following is system implementation. Historical date query statistic. User can directly view, including some important historical date of requirement, such as electric energy, current power, flow, purchase, and temperature. All about this can automatically calendar the maximum, minimum, and average value of the date within a certain time range. From Figure 2 is peak statistic, and the maximum, minimum, and average value is in the Figure 2 peak statistic. We can directly with the historical energy consumption date of requirement in the picture. Energy reference line. Users can use the function of energy reference line in the statistical analysis model. Set the energy reference line for each parameter of each requirement. Define its assemble index and achieve date quota management, which can be detailed to each workshop and each production life. Once the index exceeds the limit, the system will automatically learn. Figure 3 is reference post. And the next is compression of requirement energy consumption. User can use the requirement energy consumption, the function in the statistical analysis model, to achieve the energy consumption compression of the same type of equipment. The workshop and the factory cooperation of the same type. If technological can dock with some system in future, it can achieve or find equipment efficiency. Energy PEC Enterprise provides smart reporting capability for enterprise. The ability to customize report templates, provide report design tools and experts, save and print energy report. From the figure, we can see that the figure provides report design tools, expert tools, save energy and print energy report. And the conclusion about this paper is that a date acquisition model of intelligent model matter based on Wi-Fi is designed in this paper through analyzing the detailed date of chip and some Wi-Fi model. The circuit diagram of this model is designed and code of related hardware is written, and the design and development of intelligent matter date acquisition model based on Wi-Fi is realized. And from this paper, we can see that from this picture, we can see 3 technological devices. Maybe some is phone, laptop, and some iPad. If some enterprise use our system to view their energy consumption, they can use some mobile devices to check on. If you set up our application from this picture, you can enjoy your report about your energy consumption from your phone. That's so on, you also can check it from your pad and laptop. And from Figure 3, capital with computers, phone, and tablets. At last, a data model of intelligence matter based on Wi-Fi is designed in this paper. Through analyze the detailed data of chip and model, the circuit diagram of this model is designed and code of related hardware is written, and the design and develop of intelligent metadata model based on Wi-Fi can be realized. From this paper, we design a system to build more convenience for our buyer. Someone can use our system to check their energy consumption about their workshop or some business house. And after you check on what's your consumption about the energy, you can build more way to save energy or to change your machine in your workshop. At last, we also have some defects from the system. For example, we should use more software in our system, and we also should make it more convenient to check up. The data model of intelligence matter also based on Wi-Fi, so the whether Wi-Fi is stable is an important question. It can design in the paper through analyze the detailed data and some model. The circuit diagram of this model is designed and code of related hardware is written. And the design and development of intelligence metadata acquisition model based on Wi-Fi is related. Dear judges, I'm going to introduce intelligent water scheme designed based on artificial intelligence, Internet of Things, and big data technology. The authors of this paper are Yang Tao and Ma Jinquan. They are from Shenzhen Chrome Soft Company. The present paper can be summarized as implementation of this project can effectively solve the problem of water shortage in urban economic development, change the single water supply pattern of Nanshan district of Guangzhou, drawing peak water from waterway in the lower river, and Shenzhen and Dongguan, drawing water from Dongjiang River, and improve the water supply safety and emergency reserve capacity. The core of this paper is discussion of the keyword including water supply, safety, informationization, intelligent design. The following is introduction. In the Peril River Delta project aimed to optimize the allocation of water resource in the east and west of Peril River Delta, diverting water from the Xinjiang River system in the west of Peril River Delta network to the east of Peril River Delta. The main water supply target is the water deficient area in Nanshan District, Guangzhou, Shenzhen, and Dongguan. Implementation of the subject can efficiently solve the water shortage problem in the development of urban economy. The changing of Guangdong Nanshan District water from Xiawan Waterway downstream Beijiang River and Shenzhen Dongguan City from the single-way supply pattern of Dongjiang water, improve water supply safety and emergency support capability, improving downstream Dongjiang River flow, water ecological environment, appropriate to the maintenance of Nanshan District, Guangdong, Shenzhen, and Dongguan City water supply security, and sustainable economic and social development plays an important role. After the completion of project, the average water supply for many rivers and for many years was 0 billion cubic meters, including Nanshan District. The following is the project consists of one main line, two branch line, one branch line, 3 punching stations, and a newly built regarding reservoir. The project draws water from Liushui of Xinjiang River and transport water to Gaoxinshan Reservoir. The design diversion flow rate is 80 cubic meters per second, and the total length of water transmission line is 130.2 kilometers, of which the trunk line is 80.3 kilometers long, including Dongguan sub-trunk line, with a length of 3.6 kilometers. Shenzhen branch trunk line is 11.9 kilometers long. Nanshan branch line is 7.4 kilometers long, and Gaoxinshan Reservoir is nearly built. The storage capacity is 4.83 million cubic meters, and Dongfor, such as the project size is very large. The following is system design. Overall plan with reference to preliminary design review. Follow the wisdom water resource overall plan and the water later level action plan for 3 years. Relevant required. The use of Internet of Things, cloud computing, big data, artificial intelligence, 5G, such as a new generation of information technological, focusing on engineering construction, water regulation, project operation, emerging disposal, such as core, select core, business, optimize the overall structure, optimize the platform construction, strengthen the construction of data, deepen the resources integration, expand application of wisdom, provide scientific decision-making, fine management, and comprehensive regulation of effective support. Originalization science, advanced knowledge, quality control process can be tracked back to the wisdom of project objective, as shown in Figure 1. The following is system implementation. The first is overall architecture. The Pearl River Delta Intelligence Water Conservancy Project, mainly including a network, a brain, and 7 intelligent applications. A network is mainly composed of the interaction of things and high-speed intellect, connecting information network connected with various monitoring devices. A brain is mainly composed of engineering cloud, big data, and Taiwan e-project. 7 intelligence applications, merely including intelligence, constructing, and management. Intelligence supervision, intelligence decision-making, intelligence scheduling, intelligence emergency response, and intelligence operation and maintenance, and intelligence experience. We can see Figure 2 for detail. The next is data resource model system, expression of engineering project model organization according to the data resources, reduce data redundancy, improve the ability of flexibility, and easy connection between data structure. The object is divided into identity and attribute of object ID. Identification only express ontology and extents and uniqueness of the attribute is the ontology of possible relay information, such as basic attribute, spectral and attribute, BIM properties, as well as logo or attributes are possible when phase checkers, as shown in Figure 3 below. The following is conclusions. In terms of time series, it covers all stages of whole life cycle, such as project planning, construction, operation, and maintenance, with a large time span. In terms of content composition, it covers perception, automatic control, network communication, physical environment, basics hardware facilities, data center, intelligence platform, application system. In terms of technology, IT includes monitor technology, communication technological, industrial control technology, intelligence hardware network technology, physical environment construction, technological, cloud computing, big data, artificial intelligence, technological, BIM plus GIS, and other technology, software development, technology, water conservation, conservancy, professional business, and other technological in terms of system integration. It includes data integration among industrial control network, business network, and internet, data and process integration with Water Resources Department and Ministry of Water Resources. Security, automatically, and process integration with provincial government affairs, data sharing and exchange with other departments from the point of construction units, including a number of different professional types with different technological expertise, different sections of the construction unit, and also from the conclusion about how to ensure the home service, multiple unit construction technological, construction content to plan as a whole classes for an organic well from a joint collaborate community can realize such content. Several construction units to running homeowners each other to achieve high quality division of labor comprehension to ensure that the project, the Ministry of Water Resources, and Provincial Water Resource Bureau, the other parts of integration can guarantee the construction entity share according to the general technological requirements, the overall schedule, the overall group of all tasks efficiently and orderly organization work must need to have a comprehensive ability to fall to the ground the total integration of units under the overall command of owner, under the supervision of the supervisor, and the requirements of design program and road, cooperate with all participating units to participate in project construct. And also we can know that from the conclusion, how to ensure the home series can guarantee the construction entity share according to the general technological requirements, the overall schedule, the overall goal, all tasks efficiently and orderly organization work must need to have a comprehensive ability to fall to the ground, the total inclusive. And under the supervision of supervisor, the Provincial Water Resources Bureau, the other part of integration between, can guarantee the construction entity share according to the general technological requirements, the overall schedule, the overall group, all tasks efficiently and orderly.
Energy and Cloud, a new energy management system. University of Electronic Science and Technology of China, Zhongshan Institute, Zhongshan. Abstract. The main purpose of this project is to systematically monitor and analyze the power consumption in the industrial park of Skyward's rock base and give early warning of the equipment temperature. There are a total of 33 measurement monitoring points and temperature monitoring points in the industrial park of Skyward's rock base, which monitor and control the electricity consumption in the research and development building. Concentric building, complex building, water pump room, and other areas in the industrial park. Keywords: analyze, warning, monitoring, fine management. Introduction. Energy use is an essential part of all consumer business. Electricity, water, steam. Repeat energy consumption includes the cost of production and management, how to save costs and manage it effectively has always been a very difficult problem for enterprises. At present, energy shortage and environmental degradation have become the biggest problems facing the world. In recent years, the global economy continues to high-speed growth and meanwhile, the excessive use of water resources become the priorities of global social development over the past couple of years. However, as the economic growth at the same time also triggered the global energy supplies and cause enormous pressure to environmental protection. The development of these problems require from the individuals to the company must shoulder the responsibility of the social development, take effective measures to reduce in energy consumption. The Chinese government attached great importance to energy conservation and environmental protection enhancement. Energy conservation and efficiency in fundamental part of its national strategy by 2050. China's energy consumption per unit of GDP will be 16% lower than that of 2010. Industry energy consumption industrial at value for much above 1%. The implementation rate of green building standards reached 15%. As a provider of higher quality energy information, management system. Tool helps users to improve their business effectiveness by helping enterprise to effectively manage various enterprise environment, energy, and continuously reduce energy consumption. Cochlear has 8 years of rich industry experience, surveys more than 100 enterprises, business involved in more than 30 industries. Every step of energy use, our solutions can help you save energy costs by 50 to 30% per year, reduce input costs by about 17%. Through system design, the architecture of the energy management platform is showing the following figure. The platform is mainly composed of 3 layers, namely the application layer, the data transmission layer, and the data equalization layer. 1. Data acquisition layer. It is mainly composed of various measuring instruments through which data acquisitions of various energy output can be realized. The instrument is a direct acquisition equipment of energy consumption data, so its stability and accuracy are very important to the system. 2. Data transmission layer, mainly composed of data repeater. It realizes data transmission from data acquisition layer to application layer through data transmission layer. The data repeater requires stable signal and strong anti-interference ability. The data repeater is responsible for the unified reception of the scatter transmitter information and serves as the summarized gateway to transform the information and data of each device to the cloud service platform. Application layer, mainly composed of cloud service platform and clients. It realizes the manual collection, storage, analysis, and management of data. Cloud service platform is the core of the energy management platform, integrating collection, storage, analysis, and management, while the user is the embodiment of the energy management platform. Is to provide users with a variety of energy management data analysis tools to help end users achieve energy data analysis and management, provide clear data support, help enterprises to improve the efficiencies of energy use. The user supports the user of multiple users and devices, mobile phones, tablets, work computers, system intention. 3.1 Jupiter Energy Data Terminal. The Jupiter Energy Data Terminal is an intelligent power monitoring terminal with built-in data storage to measure current, voltage, power power and so on many electric parameters with a built-in clock and large capacity storage function. The time interval can be set according to historical data, frozen and stored in electronic matter internal storage medium with wire and wireless communication function can be convenient to read out instructions stored in real-time and historical data. Business Intelligent Data Relay. Business Intelligent Data Relay is an intelligent data repeater capable of collecting and forwarding energy data from JTFA, energy data terminal, and Mercury data converter. Mercury Intelligent Data Converter. Mercury Intelligent Data Converter is an intelligent data adapter that can transform Modbus protocol as acquisition equipment. It is suitable for converting and storing data of data quality streams with Modbus protocol, such as intelligent flow meter and existing intelligent electricity meter, to Mercury and sending the data to the enterprise private cloud computing center through the government staff data repeater. Conclusions. From the perspective of enterprises, energy and cloud energy management solutions provide enterprise management high visibility of energy use and consumption and assist enterprise decision makers in formulating and implementing energy conservation and efficiency management strategies. 1. Rapid diagnosis of energy user problems and impacts to accelerate the promotion of energy conservation and efficient. 2. Highly integrated equipment operation and energy consumption information. Realize remote cost, low energy management, optimize workflow, and maximize production efficiency. Establish a high quality and extensive energy management system, which lies a good foundation for enterprise to meet development and environmental challenges and establish digital management. Thus, in the fierce competition of the market in favor of the unbeatable price.
Hello everyone, my name is Sun Zhang. I'm a master student from Nanjing University of Aeronautics and Astronautics, and I'm currently doing some research on visible light communication. Today, my report title is a novel parking lot occupy detection system based on LED sensing. My presentation will include these 4 parts. Firstly, I will introduce the background of our research. Secondly, I will demonstrate the detection system we have proposed in paper. Thirdly, I will show the evolution of my system performance. And finally, I will enumerate some conclusions we have got. Now, let me move into the first section, an introduction of my research. Now, with the growth of civilian vehicles, more and more underground parking lots have appeared in cities. The essential issue is an intelligent parking management system is to detect currently if the parking lot are occupied by vehicles. This figure existing parking management system generally deploy the cameras, electronic detectors, pressure sensors, and so on for occupy detection. This picture shows using wide-angle camera for detecting parking space. But this system generally requires the deployment of extra equipment at the parking space. What's more, some systems even need ground reconstruction. But fortunately, economic and energy efficient LED emitters are widely used in underground garages. In this picture, this parking lot uses LED area as the lighting infrastructure. This is LED area. Based on photoelectric effect of LED, we can use LED as a lighting sensor to sense the ambient light intensity. As the occupy of parking lot will impact the light diffusion reflection. The occupy of parking lot will affect the lighting diffusion reflection. LED sensor is an ideal candidate for occupy estimation. The main contribution of my paper are as follows. Firstly, we redesign the driver of the LED emitters and switch them between the LED eliminating state and the sensing state. Secondly, during the sensing stage, the LED eliminators sense the ambient light diffusion reflection and then feed the sensing measurement to SVM algorithm to infer the occupied results. Now, let's move into the second section. Design detection system. At first, as shown in this picture, when a vehicle enters the parking lot covered by an LED area, the LED can capture the change of LED diffusion caused by the vehicle movement. So, in order to enable the LED area to switch between the LED emanating and the sensing state, the LED area need to connect the MCU by a bidirectional interface. The figure 5 and table 1 show how to control the state transaction of LED. In the LED lighting state, the port A outputs the VCC signal and port B is grounding. At this time, the LED is in lighting state. When the LED area is to be used for LED sensing, the port A is grounding and port B output VCC signal. Because the internal carry capacities of the LED array need to be charged. During the LED sensing stage, port B switch to input state. Port B switch to input state for reading system signal. After this, we redesign the LED driving circuit to control the state transaction of LED. Look at. We redesign the LED driving circuit as in Figure 6. When both switch 1 and switch 2 are turned on, and other switches like switch 3, switch 4, switch 5 are turned off. Only LED array is connected in secret LED array and eliminate. When only switch 3 are turned on, and other switches are turned off, the LED array is ready to light sensing stage. Only switch 3 turn on. When switch 4 and switch 5 are turned on, and other switches are turned off, the LED array switches to the light sensing state. After we redesign the LED state transaction circuit, we conduct expensive simulative experiment to verify the proposed LED sensing-based parking lot occupancy system. Firstly, we simulate a vehicle parking situation. As mentioned earlier, when a vehicle enters the parking lot covered by a LED array, the LED array can capture the change of LED diffusion caused by the vehicle movement. So, and showing this right picture, during the first second, there is no car in the parking lot, and the LED reading is in a low level. The following 60 seconds, a vehicle enters the parking lot, and the LED reading increases largely and stay in a high level. This implies that the occupy detection can be realized by comparing the LED reading difference. But we are also explore the impact of the vertical height on the LED reading. With the distance vary from 40 centimeters to 100 centimeters, the change of LED reading became more insignificant. Through investigating the distance of the vehicle roof and the LED array is roughly 40 centimeters to 120 centimeters. which means the proposed LED sensing-based occupy detection is feasible to LED reading. Besides the height, vertical color also can impact the LED reading. As shown in this picture, when the color is white, the LED reading is most significant, and black incurs the most trivial change. This conforms to our intuition since the white object reflects the light of all colors, and on the contrary, the black object absorbs all light. After we get the LED reading, we use an exponential moving average method to remove noise from the raw reading. Then, like this. Then we feed the smooth LED reading in SOM classification algorithm, like this. The parking lot occupy can be formulated as a binary classification. We use accuracy and precision to evaluate the performance. Accuracy and precision. As shown in this table, when the distance of warehouse and LED area is 40 centimeters, the accuracy rate of the detection results of the SVM algorithm reaches 98.70%. The accuracy would stay above 86.04% as the vector distance is generally below 100 centimeters. The accuracy can be further improved by increasing the LED areas. Finally, let us see what we conclude here. In this paper, we reuse the existing lighting infrastructure and exploit the light sensing capacity of LED to detect the occupy of the parking lot. LED can work as light sensors. We conduct a simulation and demonstrate the feasibility and effectiveness of the proposed LED sensing based parking lot occupy detection system. Once more, our system only considers the LED deployment that 1 mm is mounted on the top of one parking lot, like this. 1 LED emitter is mounted on the top of one parking lot. But in order to save cost, a single LED emitters may cover multiple parking lots. One LED emitter may cover multiple parking lots. Therefore, we plan to verify the feasibility of one LED emitters monitoring multiple parking lots in the future. That's all. Thank you.
The topic of my paper is Assist GPS to improve accuracy under complex road conditions using sensors on smartphone. The outline of my talk is as follows. The first part, I want to introduce the background of this research. The second part introduces problem definition and modeling. The third part introduces how to solve the model. The fourth part evaluates the method, and finally the conclusion is given. Well, let's move on to the first part of this topic. The motivation of this topic is like this. Location tracking techniques are now widely used in many location-based services, such as car navigation and logistics management. The GPS has high precision outdoors. However, its tracking accuracy will be greatly affected in some scenarios. For example, it will have large error when the signal is bad. Also, when there are roads interlaced, the accuracy can be influenced. More detailedly, when the car is driving in a tunnel or under dense tall buildings, the GPS signal will be very weak, and the tracking cannot be precise. Another example is that when the car is passing the overpass, there may be several roads at different altitudes, but under the same GPS longitude and latitude. The altitude provided by GPS can have an error of tens of meters, which is not accurate enough to know which road the car is driving on. Based on the above observations, an approach to improve the accuracy of GPS in such particular situations is desperately needed. This figure describes the overall structure of my method. First of all, the left part shows the application scenario of this method. The figure shows the scene of the car driving on a complex overpass. The locations in the figure are the real locations of the car passing by. But due to GPS error, we cannot get the exact locations. The middle part of the figure shows the data obtained by mobile phone. They are the road map, GPS data, barometer data, and acceleration data. After pre-processing this data, we can convert them into the parameters needed by a hidden Markov model. The part on the right shows the model we used. We used the hidden Markov model to predict the most likely driving paths of the car. We get the emission probability through GPS data and barometer data, and the transition probability through GPS data and acceleration data. Next, I will talk about the problem definition. In this paper, we solve the problem by using a probabilistic model called hidden Markov model. This model can help us get a sequence of unobserved states, which is also called hidden states. In our problem, the hidden states are the passing by locations of the car which we cannot observe directly due to GPS error. Also, the observed readings of GPS, barometer, and accelerometer depend on the hidden states. Based on the above observations, we define the problem as follows. For a moving car, given the road map M, number of time step T, and other observation readings, GPS readings, barometer readings, and accelerometer readings, the purpose is to accurately infer the hidden location list of the car. Now we talk about the hidden Markov model. There are two variables and three parameters of a hidden Markov model. Two variables are the state variable x and the observation variable y. State variable is also called hidden variable. Given a roadmap M, the state space X is all the location points on the map, and the state variable is the driving trace of the car. YT in observation variable represents the observation value at time step t on the hidden state xt. Then, three parameters of hidden Markov model are as follows. The first is the initial state probability matrix pi. The initial state probability matrix is actually the probability that the car may start from each state in the state space. The initial state probability matrix is represented as pi. Each element of pi denotes the probability that the car begins from a location state. The second is state transition probability matrix A. The state transition probability refers to the probability that every state in the state space is transferred to every other state. Each value in the state transition matrix represents the probability of transitioning from the location state at time t to the next time step. Third one is the emission probability matrix B. The emission probability refers to the probability of observation value taking OJ at a time step t given the hidden state Si. Now that we have got the three required parameters, and then we get the hidden Markov model on lambda. Next, we will get the most likely state sequence that produces the observations by using Whitby algorithm. It is given by the following recurrence relations. Here, VTK is the probability of the most probable state sequence responsible for the first T observations that have K as its final state. XK now represents the probability of transitioning from state X to state K. The Whitby path can be retrieved by 7 back pointers that remember which state X was used in the second equation. On this part will introduce how to solve the model proposed in the previous part, mainly introduce how to obtain the three parameters of hidden Markov model, and then use a modified Whitby algorithm to solve our model to get to the trace of the car. Firstly, GPS data, barometer data, and acceleration data can be acquired continuously in time series from sensors on mobile phone. After collecting this data, we pre-process this data. Since the barometric pressure and altitude can be converted into each other, we convert the barometric pressure to altitude. The state space X in our case refers to all the location points on the map. Therefore, the size of X is very large, and it will cost too much calculation. However, as the initial state's GPS value is known, the
probability of location points far from the GPS value is close to 0, and the number of these points is very large. So in order to reduce the complexity of calculation, we only consider the location points on the road within the error range of initial GPS value, and then calculate their probability according to the distance between them and the initial GPS location. We assume that the distance follows the normal distribution, where delta GPS is the error range of GPS. This figure shows an example of getting the initial state probability. We map the longitude and latitude to a two-dimensional road map and divide each road into multiple location points. This part shows how to get a state transition probability matrix A. The state transition probability in our case refers to the probability that the car moves from the previous location point at time t to the next location point at time t plus 1. We only need to calculate the probability of a point within the error range of the previous GPS point transfer to that of the next GPS point. First, the distance between all the location points with the error range of the previous GPS point and the next GPS point are calculated, and the results are represented as SG. Then we get the average speed of the car by dividing the duration time, and we get VG as the average speed. Then, according to the acceleration reading, the car speed at the previous GPS sampling point, the displacement between the two GPS sampling points can be calculated, represented as SA. Then we get the final average speed of the car by giving both of them a weight, and then we get the final average speed represented as V and AVG. Next, we calculate the distance matrix between all location points within the error range of the former GPS point and that of the next GPS point. And then we get the average speed matrix VL. For each row of VL, we assume that their values follow the normal distribution. The probability density function for average speed V average is as follows. It's like this. Then we get the state transition probability matrix A. The next step is how to get emission probability matrix B. Finally, we will estimate the emission probability for each observation. We use the combination of GPS reading and barometer reading as the observation. According to the GPS value sampled at time t, the location points within its error range are got, assuming that the distance between the GPS sampling point and this location point follows the normal distribution. The probability of these points are calculated. Similarly, we get the barometer emission probability, then we combine them together to get the emission probability. Finally, with above 3 parameters of a hidden Markov model, we maximize the probability with FAT-B algorithm and get the most probable trace of the car. Thus, we can determine which road the car is driving on more accurately. In this part, we will analyze the results of our experiment. The figure shows the map of roads for our experiment. The color change on roads represents the altitude change of road. The color bar on the right shows the color of altitude. The purpose of the experiment is to test the locating accuracy of our method under complex road conditions and compare it with GPS. Next, we will evaluate the effect from several aspects. The figure shows the comprehensive locating accuracy of our method and GPS. As can be seen from the figure, the overall effect of our method is better than GPS. The blue line is our method, and the red line is GPS. The locating accuracy of our method is 79.2%. Within 8 meters, while that of GPS is only 60. This figure uses a bar chart to compare the effects of 4 methods. It can be seen from the figure that our method is the blue one. Our method accounts for the highest proportion when the error is in the range of 0 to 5 meters, while in the range of 10 to 15 meters, the method our method accounts for a relatively low proportion, indicating that the method error is mainly concentrated in low error area. The above only evaluates the effect of these 4 methods on overpass. Next, we will evaluate their effect in the tunnel. It can be seen from the figure that 60% of the error of our method is within 20 meters, and the proportion of error over 60 meters is 0. We can figure out that the effect of our method is better than other methods in tunnel. In this paper, we propose a novel method to assist GPS tracking. The experimental results show that the accuracy of our method is 19.2% higher than that of GPS. Also, the experimental results show that the comprehensive locating accuracy of our method is better than that of other methods. However, our method still has some defects. That is, it works better when there is obvious altitude change. In addition, our method uses hidden Markov model to calculate and energy consumption is not considered. In our future work, we will consider improving the method to reduce the energy consumption and achieve higher accuracy. That's all. Thank you very much.
Hello everyone, my name is Ray Tian.
I feel honored to introduce my recent work, indoor localization based on the LoRa technology. Thanks to conference organizers about this opportunity, and thanks to my tutor Heber Ye and my classmate Li Sheng, who provide lots of help for my work. The presentation can be divided in several parts. I will start with introduction and system design. Then the experiment and evaluation is presented. Conclusion and discussion will be put at the end. Introduction. Previous work. Now please let me give a brief introduction. Indoor localization can provide a useful function for different situations, such as shopping mall or big factory. Indoor localization can help people locate an object or find them path to destination. Previous work of indoor localization take use of different technologies, such as Wi-Fi signal strength, Bluetooth, and mobile detection. The Wi-Fi and Bluetooth solution need more devices to do localization. Mobile detection take use of sensors to get the object movement. Therefore, they need a complex training process, and the error may accumulate, which will affect the localization accuracy. LoRa emergency. Recently, the NB-IoT and LoRa technologies have attracted a lot of interest in the research area. The wireless communication technologies of Internet of Things, such as NB-IoT and LoRa, may provide more opportunity for the indoor localization. LoRa works in RSM frequency band. No authorization is needed to use LoRa communication. For indoor localization, different situations have different requirements. We want to explore whether LoRa can provide a suitable solution for indoor localization. Our main goal is to locate an object which takes a LoRa device in indoor environment. Our work mainly includes the following points. First of all, we design and implement an indoor localization system based on LoRa technology. The system can provide real-time location information of objects, which carry the location equipment. Secondly, we proposed a KNN algorithm based on downsampling, which greatly reduces the size of fingerprint database. The system predicates the location of objects at the same time. Its accuracy and precision are acceptable. Finally, we do experiments in actual scene. The results show that the system can achieve an average accuracy of about 96%. System design. The next part is the system design. The localization can be divided into two phases, offline phase and online phase. The offline phase gets the fingerprint database. Based on the fingerprints, the online phase can get the location information. The system composes of hardware part and software part. The hardware is responsible for data collection. Software is responsible to do localization function. Background information. According to free space equation, the received power is negative correlation with the distance and a positive correlation with the transmitting power. The far the distance between receiver and transmitter is, the lower the received power is. Besides, the empirical model of path loss proves it again. The value of path loss PLD is positive correlation with the distance d. Meanwhile, we carried out experiments to prove that. Firstly, we use one LoRa node and one LoRa device. The RSR value is decreased with distance growth. The red line is fitted curve. Secondly, we use one LoRa node and two LoRa ones. The RSSI value at different locations makes up different groups, just like data from port 6. Generate the fingerprints. The generation of fingerprint database refers to the establishment of fingerprint database in this area. First, we introduce the format of the data transmission, as shown in Table 1 and Table 2. The data format 1 refers to the data transmission form from LoRa node device to LoRa 1 device. It contains the node device ID and node device type. The data format 2 refers to the data transmission form from LoRa 1 device to the server. It contains the LoRa 1 ID, LoRa 1 time, node ID, node time, and the RSSI value. Here we make use of the quadratic exponential smoothing to smooth the data. Furthermore, the LoRa communications are unreliable. In the process of establishing fingerprint database, some error messages exist. For example, some data is received by LoRa 1A but not by LoRa 1B. Easy to exist if the device doesn't transmit information continuously, then the device may be disconnected. This part of data should be removed. For discontinuous data, a packet propagation error may result in data loss at LoRa 1. In this case, we use a fitting method to fill in the missing value. Dynamic adjustment. Some researchers have studied the method to dynamically adjust the fingerprints database. The dynamic adjustment algorithm can improve the accuracy of the localization system. The initial setting of fingerprint database may be not effective all the time, especially when the environment changes. Furthermore, a user can manually correct the location information by a mobile phone interface application during the locating process. Localization algorithm to locate the objects. The first problem is the imbalanced data. The possible methods for the problem include upsampling, downsample, and weight the data. Keying algorithms also have some drawbacks. When the number of sampling points is too huge, it will increase the calculation of keying algorithm. We use the downsample method and keying algorithm to do localization. Experiment. First, we need to set parameters of a wireless communication device. There are mainly the following 5 parameters: the spread spectrum factor, the transmitting power, the bandwidth, the coding rate, and the wireless signal frequency. We set the same parameters in devices so that they can transmit the message with each other. We chose the Arduino board as the basic platform and connect the LoRa chip to the board to realize LoRa transmission. The system adopts Dragino LG01 as LoRaWAN device. The device contains of Arduino Yun and a LoRa chip. Here we give the data transmission path from LoRa node to LoRaWAN and to MQTT server. Indoor environment. The layout of experimental site is shown in figure. This is the plan of first floor in a building. During the experiment, there may exist a small number of people walking by. In our experiment, we totally set up 3 LoRaWAN devices and 1 node device. The node device sends 2 records per second. The LoRaWAN sends the data from the node device to the remote server. Data setting. From the experiment, we get the observed data. Then we pre-process this data and generate the fingerprint database. The collected data are sorted like a matrix. From 3 different LoRaWAN, we get the observed data value. We use drawing tools to depict the collected data in 3-dimension coordinates. Each dimension represents a LoRaWAN device. For different locations, the collected records are relatively independent to each other in figure. Evaluation accuracy. In order to evaluate the accuracy of localization, we try using different machine learning algorithms for localization. We use SVM, support vector machine, cut decision tree, and KNN, k-nearest neighbor methods to train the model. Using the data obtained from the measurement, localization result is shown in table 3. Indoor localization using KNN methods can achieve promising accuracy, about 1960%. From the same time, we know that the key value of KNN algorithm have influence on the result. We calculate the different key value of KN to study the parameter case influence. Besides, we draw a cumulative distribution function curve of these 3 methods. Of these 4 methods, we can see that the KN method is better in most of situations. Thus the green line. We use different volume of data to test the system, and we draw the graph to compare the training time and predication time. To test the location delay of the algorithm and the different data volumes, we use the collect data for evaluation. The following figure shows the time spent on completing the train and test in corresponding data volume. As can be seen, the cut decision tree and the KN algorithm both take less time. We think localization using the KNN algorithm is a better choice. Conclusion. In our work, we proposed the approach for indoor localization based on LoRa technology. We first studied the signal characteristics of the LoRaWAN in indoor environment and found that it is possible to use the LoRa technology for indoor localization. Then we established the fingerprint database and proposed an improved KN-based algorithm which can greatly reduce the size of fingerprint database. After that, we proposed our field study, and the results show that the system performance is good enough for our requirements. Discussion. The device is insensitive, which had a better influence on accuracy. The transmitter's power is lower, which leads to the distance of transmission is not long enough. In the experiment, the corridor problem will have an influence on the RSSI value. The RSSI value near the corridor become lower than common and tend to unstable. Our future work is to study the device-free object localization or detection. Thanks for your listening. The next is time for question and answer.
Thank you, Mr. Chair. Good morning, everyone. I come from Nanjing University of Aeronautics and Astronautics, and currently doing some research about radar target detection and simulation. I'm honored to be here and share our research results with you. Today, my topic is radar target detection based on information theory. My presentation includes 7 parts. Firstly, I will begin with a background of target detection. Target detection is one of the important rules of radar signal processing. NP criteria have been widely applied in radar systems for target detection. Detection performance can be shared according to RC curve. At present, the research method based on mature information is widely used in radar parameter estimation. It also can be applied in target detection. Mature information is applied in radar target detection, which is new and difficult domain relatively, but it is necessary to research that. In this paper, our work is mainly to introduce the target existence parameter into the radar detection system, which can use information theory to study both target detection and parameter estimation. In the detection and estimation system model, the theoretical expression of detection information is derived. The expression of detection probability and false alarm probability are derived by utilizing information theory method and NP criterion. The detection performance was analyzed and compared on mature information and ROC curve respectively. Secondly, I will have a brief introduction of the proposed model. The above block diagram is system model diagram in this paper. ST is baseband signal. V denotes coefficient of existence. Y is scattering signal. W stands for complex additive Gauss white noise. Then the received signal ZT is given as the equation 1. Then I will introduce part 3. The part 3 is detection information. According to information theory, the expression of detection information can be written as equation 3, where I is detection information. HV and HVZ denote the period and the posterior entropy of V. The HV and HVZ are given by equation 4 and equation 5, respectively, where P1 and P0 are period probability density of V. PVZ denotes the posterior probability density function of V. In this paper, taking the scattered signal as the complex Gauss signal as an example, the system model is studied. Complex Gauss scattering means the Y follows the complex Gauss distribution. The multi-dimensional probability density of Z, conditional on V and X, is given by equation 6. Thus, we can have the posterior probability density function of V as equation 7. Next, the first law and the detection part will be introduced. There are two hypotheses to detect target's existence. H0 corresponds to V is equal to 0. Target does not exist, and H1 corresponds to V is equal to 1. Targets exist. The received signal on the two hypotheses are given respectively as equation 9. Two probabilities of enters to evaluate detection performance. One is the probability of detection PD, that is its hypothesis H1, the probability having detected the target. The other probability of false alarm PFA, the probability having detected the target at the hypothesis H0. The probability of false alarm can be expressed as equation 9. A theorem is given if the observation interval is long enough. The probability of false alarm can be approximated as equation 10. The corresponding detailed proof has been given in this article and will not be described here in detail. According to definition of detection probability and equation 7, we can get the expression of detection probability as equation 11. In radar detection, NP criterion is often used. The purpose of NP criterion is to optimize the detection performance under the condition that the probability of false alarm does not exceed the tolerance range. The relation expression between the probability of false alarm and the detection is given by equation 12. According to RCQ, we can compare the detection performance of ITN and NP criterion. Then the part 5 detection information on the NP criterion will be introduced. Kondo proposed a calculation method for the detection information of NP detector. The pull words is the source of literature. The detector information of NP detector is defined as the mature information between the prior state of the target and the posterior state wake-up of the node received signal. The expression of detection information is given as equation 13. P wake-up 0 represents the probability that the target is detected as non-existent. Its expression is given as equation 14. A represents the actual existence probability of the target under the condition of the decision signal target exists. D represents the probability of the target non-existence under the condition of decision signal target does not exist. Equation 15 is the expression of A and D. Next, the numerical results and analysis part will be introduced. In order to compare the detection performance of ITM and NP, there are three parts to discuss. First, detection information with respect to SNR. Second, the ROC curves based on ITM and NP criteria. Third, detection information with respect to parallel probability. In Figure 1, the detection information is plotted with respect to SNR on the complex Gauss model. The solid curve represents the detection information curve of ITM, and the virtual curve represents the reachable region of detection information and SNR for any false alarm probability according to detection information expression of NP criterion. With the increase of SNR, the more information is obtained. Under the same SNR, the detection information of ITM is always greater than that of NP criterion, which indicates that the detection performance of ITM is better than that of NP criterion with the change of SNR. Figure 2 depicts the ROC curve based on ITM and NP criterion on the complex Gauss scattering model, respectively, and the SNR is set as 0 dB, 5 dB. It can be seen that the probability of detection increases with the increases of probability of false alarm. On the condition of the constant false alarm probability, the probability of detection increases with the increases of SNR. The probability of detection based on NP criterion is always higher than that of ITM, which indicates the performance of ITM is worse than the NP criterion from perspective of ROC. Figure 3 and Figure 4 depicts the relationship between detection information and parallel probability. The short curve represents the detection information curve of ITM, and the virtual curve represents the reachable region of detection information, and the parallel probability for any false alarm probability according to the detection information expression of NP criterion. The gentle of local minor fluctuation of the curve is obvious, because in small SNR the noise has a great influence. Also, the number of simulation samples has been large. There are still fluctuations. With the increase of SNR, the influence of noise gradually decreases, and the gentle becomes less obvious. As we can see from the two figures, the detection information of ITM is always much higher than that based on NP criterion, which indicates that the detection performance of ITM is better than that of NP criterion. The amount of detection information with respect to parallel probability on the condition of a certain SNR could be seen from Figure 1, which further verify its correctness. Last, the conclusions will be introduced. In this paper, we introduce the target existence parameter into the radar detection system, which could use the same method for target detection and estimation. And the method of measuring detection performance is introduced. Simulation results shows that the detection information of ITM is better than that of NP criteria from perspective of information theory. Finally, multi-target detection and unification of target detection and parameter estimation are worthily researched in the future work. That's all. Thank you. All questions are welcome.
Thank you, Mr. Chair. Good morning, everyone. I come from Nanjing University of Aeronautics and Astronautics, and currently doing some research about static target detection and simulation. I am honored to be here and share our research results with you. Today, my topic is research on set detection and its performance analysis in sensor array. My presentation includes 8 parts. Firstly, I will begin with the development background of information theory. Since Shannon founded the information theory, great achievements have been made in the field of communication, which laid a solid foundation for the rapid development of communication. Kando has studied the relationship between the optimal theory hold and the mutual information for radar return signal. Some researchers have studied the relationship between information theory and parameter estimation in sensor array. The sensor array system might make measurement of a source in order to determine its inner characteristics. In the work of Wood and Davis, information theory was considered applicable to radar measurement problems for the first time. Wood and Davis studied the range measure information with respect to SNR in the signal target radar detection. Few papers involve relating information theory with source detection, let alone comparing the detection performance of ITA with NP criterion, which are the core content of this paper. In the remainder of this paper, we first construct the receiving signal model of sensor array. Based on the previous research of sensor array detection information, we further discuss the detection information in constant modular scattering signal. On the basis of the reference, the relationship between detection probability of false alarm probability is deduced by using NP criterion in constant modular scattering signal, and we got the corresponding detection information. The numerical results are presented. The detection performance of ITI and NP criterion is analyzed, which shows the superiority of each method. Now, let me introduce the part of system model. Figure 1 shows a uniform linear array model. A narrow-band far-field source impinging on the antenna array and the elements. The received signals at MTH array elements. The source signal is given by S, where the scattering coefficient alpha takes one distribution, namely constant distribution, and the special phase is uniformly distributed in the interval between 0 and half of pi. Suppose the scattering coefficient alpha is a constant, S is a constant measureless scattering signal. Now let me introduce the part of detection information of source. We can define the detection information of the mature information between the special existence status and the received signal. According to information theory, the quantity of information obtainable from a sense array observation is the difference of the interface of a priority and a posteriority probability distribution, that is, constant measureless scattering means that the amplitude of the scattering coefficient of the source is a constant. The phase of the scattering coefficient of the source is uniformly distributed over the interval between 0 and half of pi. Substituting of the posteriori probability distribution into detection information, we can simulate the detection information curve of constant measureless scattering signal. Now, let me introduce the part of the RC based on ATA. In this section, we derive the theoretical expression between detection probability and false alarm probability in a single source scenario respectively, based on ATA. For simplicity, following x1 and x0 represent the presence and absence of the source in the actual received signal respectively. Step 1. In constant measureless scattering signal model, the false alarm probability PFA can be approximated as equation 1. Then we can approximate the my part of false alarm probability PFA to the form of expectation. According to the distribution of independent variables, the expectation can be reduced to a very simple form. And step 4, we can get the deserved result. Next, we will derive the theoretical expressions of detection probability and the approximate expressions of detection probability and false alarm probability in constant modular scattering signal model. Now, let me introduce the part of the ROC-based NP carry theory. According to the reference and the sister model, we have the following two hypotheses. Then, in the constant modulus model and the NP carry theory, we have false alarm probability and detection probability. Now let me introduce the part of the detection information and NP carry theory. When a source position is known, this paper adopts the relationship between the detection information of NP detector and the false alarm probability and the priori probability proposed in the reference. A indicates source real existence probability and the decision signal source existence, and D indicates source non-existence probability and the decision signal source non-existence. Now, let me introduce the part of the numerical results and analysis. In Figure 2, a priori probability of V is set equal, and the detection information in a signal source, single source detection, is illustrated, where S is a constant modular scattering signal. In the case of ADA, detection information quickly researches the theoretical maximal value 1 from 0. And the blue curve is higher than the orange curve in the whole process of SNR change, which indicates that the detection performance of ADA is better than that of NP carry theory with the change of SNR. According to the detection information curve of source in Figure 2 and ROC simulation results, we take minus 20 dB to 0 dB as observation interval, and select some representative curves to reflect the general trend of ROC curve. Minus 20 dB and minus 10 dB represent low and medium SNR interval respectively. Whether it is a blue cover or an orange cover, and the same false alarm probability. The value of the dotted cover is higher than that of the solid cover and the stem SNR, which indicates that the performance of ATA is worse than that of NP criteria in terms of reserve operating characteristics in the mid-SAW SNR range. In Figure 4 and Figure 5, we can observe that the detection information value of the blue slider curve is significantly greater than that of orange dotted curve, and the same priori probability condition, which indicates that the detection performance of ATA is better than that of NP criteria in the middle and low SNR range. This is predictable because the detection information is the theoretical value given by the information theory mask. Theoretical analysis shows that even for small and weak source, ATA has a possibility of detection, which is more beneficial to the detection of small and weak source. The above comparative analysis further confirms the reliability and effectiveness of ATA in single source detection, and also provide important guiding significance for the selection of appropriate mask for the detection of signal. Now, let me introduce the part of the conclusion. In this paper, we apply information theory to sensor array system in signal source scenario. Introduce the Boolean variable V is to indicate whether a signal exists or not in the system model, and uniform source detection with parameter estimation. Real closed form expressions between detection probability and false array probability have been derived respectively for constant measureless scattering signal. Theoretical analysis and numerical results are plotted to corroborate that the detection information of ATA is better than NP criteria, and the detection probability of NP's criteria is better than detection information criteria. At present, there is no final conclusion on which of the two criteria is the best. But our research work breaks the situation that NP criteria dominate the whole country and opens up a new direction for the field of source detection. In addition, some issues such as multi-sources detection with interference are worth of further investigation. That's all, thank you. All questions are welcome.
Hello everyone, my
My title is Analysis of Co-channel Interference between Satellite and 5G System in C-band. My presentation includes 4 parts. Communication technology is developing rapidly. 5th generation mobile communication technology will support high-speed, low latency, and large-scale access services to enhance the overall performance of the system. The World Radio Communication Conference identifies millimeter wave bands as available frequency bands for 5G radio services. The 3,400 to 3,600 MHz band is one of the most important candidate bands for 5G system. This band is also used by fixed satellite service. Causing FSS earth stations will be subject to interference from the same frequency band in 5G systems. Therefore, it is necessary to study the co-frequency interference between 5G system and FSS system. The interference caused by 5G system to FSS earth station mainly comes from 5G users and 5G base stations. However, because the transmission power of 5G base stations is much higher than that of 5G user equipment, the interference caused by base stations to FSS earth stations is much greater than that of 5G users. The following mainly studies the interference scenarios of 5G base stations to FSS earth stations. It is assumed that 5G base stations are evenly distributed around the FSS earth station in a ring. Assumed that only the co-frequency interference of 5G base stations to FSS earth stations is considered. The main causes of interference are the elevation angle of the FSS earth station, the interference power of 5G base stations, and the number of 5G interference base stations. Therefore, the interference power of single 5G base station received by FSS earth station is the following formula. When considering the interference from multiple 5G base stations, the interference power received by FSS earth station can be shown as this formula. The main parameter of 5G system and the FSS earth station system are shown in Table 1. In the simulation, the transmission power of the 5G base station is from 50 to 60 dBi, and the protection distance between the FSS earth station and the 5G base station is set to 5 km. When the aggregate interference from the base station exceeds the interference threshold, the protection distance is gradually increased to 50 km. The relationship between the interference to noise ratio of 5G base stations to FSS earth station and the protection distance is shown in Figure 2.
From the figure, we can get the lagrange of axis angle between the direction of the main beam of the FSS Earth station and antenna and the interference signal of the base station. The smaller the protection distance required for coexistence between the satellite and the 5G system. The protection distance between the base station and the FSS Earth station is 20 km. The relationship between the number of 5G base stations and the interference to noise ratio of the FSS Earth station is described in Figure 3. From the Figure 3, we can find the larger the angle, the greater number of base stations accommodated by FSS Earth stations. But as the number of 5G base stations increases, the higher INR, the greater the interference level of the FSS Earth station. Therefore, reasonable agreement and control of the number of 5G base stations is one of the important means to reduce interference to FSS Earth station. The last is a conclusion. To solve the problem of interference coexistence between satellite and the 5G system, this paper conducted interference analysis on the coexistence scenarios between 5G and FSS Earth station in the frequency band of 3,400 to 3,600 MHz. In the case of co-channel interference, we only consider the interference of 5G base station to FSS Earth station. Through the performance simulation, we get the protection distance between systems should be at least 15 to 20 km. Besides, the interference of 5G to the FSS system not only lies in the angle between the main axis of the FSS Earth station antenna and the interference signal of the 5G base station, but also depends on the number of 5G base stations and the transmission power. Thanks for your listening.
Hello everyone, my title is Characteristics Analysis and Modeling of Satellite Mobile MIMO Channel. I will explain it in 5 parts, including Introduction, Characteristic Analysis of Satellite Mobile MIMO Channel, Modeling, Simulation Analysis of Satellite Mobile MIMO Channel Model, and Conclusion. The first part is the introduction of this paper. MIMO technology improves the communication quality by using multiple antennas at the transmitter and the receiver. It can make full use of the space resources and increase the channel capacity of the system by multiple times without increasing the spectrum resources and antenna transmitting power. Because of these advantages, MIMO technology has been widely used in ground MIMO communication, which is regarded as the core technology of mobile communication and has epoch-making significance. However, the distance between the antennas of the ground MIMO system is more than half a wavelength, which is independent of each other. What's more, the size of the satellite is very small and it's not easy to meet the condition of the antenna distance of half a wavelength. Moreover, the satellite link formed by the satellite in the space segment and the ground mobile terminal is very long, so it's bound to have a strong correlation to place multiple antennas on a single satellite. Because of this difference, the modeling of MIMO channel is an important research topic in the application of MIMO technology to satellite communication. In the modeling method of satellite MIMO channel, there are two main methods. One is the probability statistical model that simulates the signal propagation characteristics by combining different probability density functions. Constellation proposed a detailed modeling method in 2010. The other is a geometric model that describes the signal propagation characteristics through scattering theory and retracing theory. In 2013, a German research institute proposed a channel modeling method based on geometrics. In addition, in terms of channel state transition models, the three-state model proposed by Fulton around 2000 was more commonly used. After that, he proposed an improved two-state model. On this basis, this paper used the two-state model to build a probability and statistical model. The second part is characteristic analysis of satellite mobile MIMO channel. In the aspect of analyzing the channel characteristics of satellite mobile MIMO through the actual measurement results, there are 3 points that can be summarized from the channel characteristics. In the statistical sense, the probability density function of the signal envelope is studied. The experimental data is subjected to the KS test to know that the large-scale fading conforms to the log-normal distribution, and the small-scale fading conforms to the race distribution. In terms of the correlation between subchannels, only the signals with short time interval in the large-scale fading have a close correlation in the time domain, and the small-scale fading is weakly correlated. Satellite mobile MIMO channel has the correlation between channels, which is the biggest difference between it and the terrestrial MIMO channel. It is also an important part that cannot be ignored in modeling. The third part is the modeling of satellite mobile MIMO channel. On the basis of characteristics analysis, channel modeling is carried out, and the assumed modeling scenario is like this. In the scenario, 2 multiply 2 MIMO channel is selected. That is, GEO satellite at the sending end and a mobile terminal at the receiving end adopt dual circular polarization antennas. Since the multiplicative echo has no significant expansion in time, the resulting fading channel is assumed to be narrowband. The modeling method will be divided into 4 parts in detail below. The first part is the use of two-state Markov chains. In this paper, the two-state model proposed by Fulton is used instead of the three-state model. Therefore, the mathematical model of this step is also simplified from 3-state to 2-state Markov chain. The original line of set transmission, medium shadow, and deep shadow are changed into good state and bad state. The next time of the channel may be to keep the original state unchanged, or switch to another state. The probability of state transmission constitutes the transition matrix. This is the probability density function and cumulative distribution function of the signal envelope under the Lu model. The parameter triples can be summarized from its distribution. Among them, alpha is the mean, phi is the standard deviation, and MP is the average energy. They will be used in the subsequent large-scale fading modeling process. Unlike the commonly used fixed-value parameters, the value of the parameter triplet in the two-state model has a certain degree of randomness. The following is the modeling part of the satellite mobile MIMO channel. I will give the modeling methods of the large-scale and small-scale fading parts respectively. This is the modeling block diagram of the large-scale fading part. The upper part of this block diagram is to introduce time correlation and MIMO correlation. In the second part of the channel characteristics analysis, we know that only the signals with close time intervals of large-scale fading have strong correlation. Therefore, each subchannel generates a Gaussian random sequence and uses this formula to introduce the correlation between the subchannels. Because placing multiply antennas on a single satellite will have a strong correlation, the next step is to introduce MIMO correlation. The introduction of MIMO correlation needs to use the previously generated Lu parameter triples, alpha, phi, and MP. Then the phase and polarization effects are introduced. The phase effect is considered to be random in the initial phase, and the phase increases by delta phi at each simulation point. The power allocation formula for large-scale fading is the following, in which the parameter bit is obtained by inversely derived from the known XPD. Then there is the modeling block diagram of the small-scale fading part. The upper half of this block diagram introduces Doppler frequency shift through a low-pass Butterworth filter to generate a Rayleigh sequence. Then use a similar formula to introduce the correlation between MIMO channels. However, unlike the large-scale part, matrix C in the formula is obtained by the Kronecker product of matrices RTX and RRX. By simplifying the Kronecker product, a simplified calculator formula for matrix C can be obtained like this. Finally, this is the power distribution of the small-scale part. This is a block diagram respectation of the complete modeling process. Combining the corresponding addition of the two parts of the matrix, the channel matrix describing the channel characteristics is obtained, which is the result of satellite mobile MIMO channel modeling. The fourth part is simulation analysis of satellite mobile MIMO channel. Based on the established model, this part carries on the simulation analysis to the satellite mobile MIMO channel model. Because the 1% outage capacity can reflect the system performance, some parameters are changed on the basis of the above simulation to observe their impact on the system performance. This figure reflects the impact of the simulation environment on the system performance. Analyzing the curve, it can be found that the system performance of the open rural simulation environment is the best, and the urban is the worst. This is because the open rural environment does not have too many shelters to cause a particular serious decline. The parameters of the urban simulation environment come from Guildford, UK. Most of the measurement results are traditional British buildings. The walls are made of fired bricks and mortar, and the roof is made of slate. These man-made physical structures form a large number of shielders and scatterers near the receiving antennas. As for the comparison between MIMO and the CISO system, it can be seen that, in terms of interruption capacity, the MIMO system has twice the performance of the CISO system, which is in line with the previous introduction to the MIMO system. This figure reflects the impact of antenna cross-polarization discrimination on system performance. It can be seen that a larger XPD can improve system performance. This is because it can increase the channel gain between antennas with different polarization modes, thereby improving system performance. This figure shows the impact of satellite elevation angle on system performance. It can be seen that a larger elevation angle can improve system performance. This is because an increase in elevation angle reduces the probability of signal blockage, thereby bringing the performance improvements. The last part is the conclusion of this paper. This paper summarized the characteristics of the MIMO channel through the analysis of measurement activities. And this paper gives a modeling method of the narrowband satellite mobile dual polarization 2x2 MIMO channel model based on two-state Markov chains. On this basis, the influence of different parameters on system performance is simulated. It is concluded that the performance of MIMO system is significantly better than that of the CISO system. Different simulation environments will significantly affect the performance of the MIMO system, and open rural is the best while urban is the worst. Large cross-polarization discrimination and satellite elevation can improve the system performance. All of them provide theoretical support for the application of MIMO technology in satellite mobile communication system. That's all. Thank you for your listening.
Dear judges, I'm going to introduce design and development of intelligence metadata acquisitions model based on Bluetooth technology. The authors of this paper are Xianying Lai, Lai Xianyi, He's from University of Electronic Science and Technology of China, Zhongshan Institute. The present paper can be summarized as, at present, the common communication interface, Wi-Fi, and so on cannot meet the power requirements of embedded device, but the Bluetooth devices has attractors of low power consumption and strong anti-interference ability, and can meet the demand of intelligent matter wireless communication service. This design will focus on the practical application of wireless Bluetooth communication system in intelligence matter. Using the wireless Bluetooth communication system to connect the smart meter with the household applications, the power information such as household applications can be fed back to the power grid, which provide the possibility of the intelligent control of the smart grid. At present, we use a lot of communication interface such as Wi-Fi and some old technology. However, this technology cannot meet the power requirements of the embedded devices. So we want to use the Bluetooth devices because it has the characters of low power consumptions and strong anti-interference ability. Besides that, Bluetooth technology can meet the demand of intelligent matter wireless communication service. This design will focus on the practical application of wireless Bluetooth. This communication system in intelligence matter use the wireless Bluetooth communication system to connect the smartphone and connect the smart meter with the household applications. The power information such as household applications can be fed back to the power grid, and this can provide the possibility for the intelligent control of the smart grid. The keyword of this paper is discussion of the keywords like Bluetooth, smart meters, Internet of Things. The following is introduction. Foreign electronic matter development is pretty fast, such as Finland, Sweden, Norway, and some countries such as France, Britain, Germany, Spain, and Italy. Other Western Europe country has completed 100% electronic business user with our matter. User tables are also make a gradual transition to electronic ones, such as those that have been discontinued in French sense, and those that have been updated in Italy science last year to automatic matter reading, while 80% of British residents now use electronic matters, starting in this year as the era of smart grid. The number of smart meters installed worldwide will reach several million in 2015, and the main market for smart meter is expected to remain dominated by Europe and North America in the next 5 years, while Asian countries, driven by mainland China, will become potential markets. The following figure shows the intention of three-phase smart electronic city. This is a change in the way of collecting electronic information, but also a change in the development of science and technology smart grid. Last year, China formulated a smart grid development plan. According to the plan, China will be fully build a unified, strong smart grid. Moreover, China is expected to add 416 million smart meters during the 35 years plan. And the International Energy Agency estimates that the smart grids will cover 80% of world's population. And foreign and starting this year as the era of smart grids. The number of smart meters installed worldwide will reach 200 million in 2025, and the main market for smart meters is expected to remain dominated by Europe and North America in the next 5 years. There are a change in the way of collecting electricity information. It's also a chance in the development of science and technology and smart grid. In July, China formulated a smart grid development plan, and from this plan, we will fully build a unified, strong smart grid. Besides that, we are expected to add more smart meters in our residential part during these 4 years or 5 years. And the Internet Energy Agency estimates that the smart grids will cover 80% of the world population. And the system design. The following is from system design. Intelligence method that acquired model system based on Bluetooth technology consists of hardware part and software part, in which the hardware part including Bluetooth module, intelligent matter, and collector. The software part including the improved design of Bluetooth protocol stack and application design of mobile phone. And all of this is the main model of main chip, processing the data transmission through the Bluetooth module, forwarding the collector for data. After that, receiving the collector's response date is forwarded to Bluetooth communication module. The function of whole project is mainly composed of 2 parts. The first is data communication, though through Bluetooth master-slave communication module. Besides that, smartphone matter reading unit using mobile phone, smart operating system, and Bluetooth module to use Bluetooth to make communicate, and complete the collection and setting of electric data of waiting hour matter, and have basic weaving, date and freezing service. Smartphone matter reading unit use the mobile phone smart operating system and Bluetooth module to use Bluetooth communication, make some communication. Consider the above system online. the specific communication model of what-hour matter, the characters of Bluetooth and smartphone. The technological scheme consists of 3 hardware parts: what-hour matter, Bluetooth model, and smartphone. From the Figure 1 system design block diagram, Bluetooth model, collector, and smartphone matter reading software are the core parts of this design, including hardware and software design and implementation. The hardware parts including the selection and application of the model, the layout of circuit, the software parts including the design of communication scheduling degree between the collector and Bluetooth main model, and the design of transmission code between the matter or the collector, the communication protocol is to send and receive commands between the what-hour matter and Bluetooth model. The Bluetooth communication between our model will work fluently. The following is system hardware design and actualize. Introduction of model. High performance, low power, single phase, intelligent matter, and some great chip. The internal integration of Cortex M0 processor, clocking management, power management, hardware automatic temperature, high frequency RC, low frequency RC, LCD driver and other units, as well as NAVIC and debug function. The RTC unit which support the compensation mentioned percent. The chip use some crystal clock source as RTC clock source. Through the clock automatic digital compensation unit integrated inside the chip, it helps the user to realize the RTC automatic compensation without software participation. From the figure 2, we can see that HT6015 chip block using ARM Cortex M0 CPU core and high speed, low power, RTC support per second compensation mechanism, and Bluetooth communication model. The rich analog and digital are intelligent, which can interact directly through a programmable system without CPU interaction. The flexible enable you to connect SPI digital interface. And in the table 1, we can see hardware connective model. System software design and design of matter reading software is following. At present, most smartphones have Bluetooth model. The first step of monophone matter reading program to open the Bluetooth program. The monophone install matter reading application and the Bluetooth model in a matter to connect. The second step to create a good transmission channel with Bluetooth serial devices, and then according to matter to generate a variety of command flow The instruction stream is sent to Bluetooth model, and the return information is collection. And the model phone program can also find the received and set long information or send them to remote temporary function directory. This 5 points is about function declaration, meta setting, automatic collecting, manual collection, query Equalization, clear log. 6 and 7 is open Bluetooth and connect Bluetooth. From figure 4, we can see that software must design block. System debugging is in following. As shown in figure 6, the burner is connected to the Bluetooth model. After opening the server port test, the above see the Bluetooth model using for this design can be seen after connection can normally send and receive date. Figure 7 is system display effect. And conclusion. This paper collects electricity demand data from concentrator through Bluetooth model and displayed it to the intelligent matter.
The title of the paper is GEO and IGSO-based hybrid global coverage satellite constellation design, and I will introduce this paper from these 4 parts. The first part is about the introduction. Building a satellite mobile communication system with global communication capabilities is one of the important issues to be solved in China's globalization strategy. The low orbit, medium orbit, or high orbit satellite constellation can be used to achieve the goal of seamless global coverage. For the design of low orbit global coverage satellite constellation, Reader proposed the best polar orbit design method. Walker et al. Proposed the inclined circular orbit design method. The algorithm is a typical polar orbit low orbit constellation with a total of 66 satellites evenly distributed on 6 orbital planes. The inclination of the orbital planes is 90 degrees. The altitude is 7,080 kilometers. The eccentricity is 0 and the distance between eccentric surface is 60 degrees. It can achieve global continuous coverage in the case of communication elevation angle greater than 8 degrees. Edison system is a typical medium orbit constellation based on the design method of inclined circular orbit. It is composed of 12 stars and distributed on 3 orbital planes, each of which has 4 stars. The orbital height is 10,354 kilometers, which can provide a communication elevation of 22 degrees. Inmarsat is a typical high-orbit constellation system using GEO satellites. It consists of 3 GEO satellites. High-orbit and low-orbit systems have distinct characteristics due to their different orbital heights, numbers of satellites, and technical means. Considering the current development situation in China, choosing a GEO system with relatively low technical complexity and high cost performance is a good solution. However, relying on GEO satellites alone cannot provide an ideal communication elevation angle for high-latitude areas, and there will also be coverage blindness for polar region. The IGSO satellite has an orbital shape due to its non-zero orbit inclination, which can provide high elevation angle coverage for high-latitude areas. This paper designs a GEO plus IGSO satellite constellation based on such considerations. The part 2 explores the features of the IGSO satellite. The GEO satellite is stationary relative to the ground, so its ground track is a point and is always located at the Earth's equator. On the one hand, this feature of GEO determines its good coverage characteristics in low and medium latitude regions. On the other hand, it also limits its coverage capability in high latitude regions. There will be blind points in the polar region if you want to use the GEO system for global seamless coverage. This is a problem that still must be solved. This is an issue that must be addressed if the GEO system is want to be used for seamless global coverage. The IGSO satellite orbits at the same latitude as the GEO satellite and has the same period of operation as the GEO satellite. It is also synchronized with the Earth. However, the orbital inclination of the IGSO satellite is not zero, which determines that the ground track will not be a point like GEO, but an H shape, thus providing high elevation angle coverage for high latitude areas. There are two main orbital parameters for IGSO satellites: orbital inclination and longitude when the ground track crosses the equator, similar to the ground track of GEO satellite. The ground track of IGSO satellite will always pass through the same point on the equator. Therefore, the longitude of this point can be used for unique identification. Since the IGSO satellite will always move around this point, the location of this point determines the approximate coverage of the IGSO satellite. The larger the orbital inclination is, the larger the it will be, and the better the coverage of the polar and high latitudes will be, while the coverage of the middle and low latitudes will be reduced. When choosing the IGSO inclination, the influence of these two factors should be considered in a more specific, strategic, and tactical compromise. The related research shows that the use of IGSO satellites can significantly improve the low elevation angle problem of GEO satellites in high-latitude areas. The constellation composed of 2 or 3 relatively small IGSO satellites could achieve better performance than a very large GEO satellite. The IGSO satellite constellation can be used to realize the continuous multi-star coverage of China, and the effective diversity can be realized, which can obviously improve the anti-interference capability of the system. If the coverage of high-latitude regions is required, 3 IGSO satellites are needed to ensure performance. So in this paper, 3 IGSO satellites with common ground track are used to cover the Chinese and nearby area. Part 3 is about the hybrid global coverage satellite constellation based on GEO plus IGSO. First is the performance indicators of global coverage satellite constellation design. This paper analyzes the coverage performance of the constellation based on STK. The goal of the constellation design in this paper is to provide multiple coverage to the Chinese and nearby area, while taking into account global coverage. In addition, it is necessary to ensure a high communication elevation angle for high-latitude areas. The relevant parameters used in the analysis are as follows. The minimum communication elevation angle is 20 degrees. Covered area includes global area, the Chinese and nearby area, Arctic area. Coverage performance and elevation angle statistical accuracy and regional resolution of 10 degrees latitude and 1 degree longitude. This part is the design scheme based on 2GEO plus 3 IGSO hybrid global coverage constellation. The constellation design in this paper consists of 5 satellites, including 3 IGSO satellites and 2GEO satellites. The two-dimensional map of the constellation and the coverage of each satellite are shown in the figure, where different satellites are marked with different colors, and the coverage of satellite is represented by the corresponding border length of the same color. And this table shows the satellite orbit parameters, including the same major axis, longitude ascending node, orbital inclination, argument of Pre-G, true anomaly. Part is about the constellation coverage analysis. This paper used STK to perform coverage analysis. It can be seen from the figure that the real-time single satellite coverage of this constellation can reach more than 95%, and the highest can reach 97.4%. The cumulative coverage rate can reach 100%, indicating that the constellation can achieve seamless global coverage without carrying blindness. Real-time double satellite coverage of this constellation on the Chinese and nearby area can reach more than 87%, and the highest can reach 100%. The double satellite cumulative coverage can reach 100%, indicating that at least 2 satellites can be seen anywhere in the Chinese and nearby area within a day. It can also be found that within 1 day there are 3 pairs where the real-time double satellite coverage rate is less than 90%, and each duration is about 1 hour. In other words, the Chinese and nearby area can reach a double satellite coverage rate of more than 90% within 21 hours in a day. The real-time single satellite coverage of this constellation in the polar region can reach more than 58%, and the maximum can reach 100%. Real-time double satellite coverage can reach 100%, no coverage blind spot, and there are 3 time periods in which a real-time single satellite coverage rate is less than 80%, each of which is about 3 hours. So 62.5% of the time during the day, more than 80% of a single satellite coverage rate can be obtained in the polar region. The last part is about the conclusion.
This paper used the advantages of IGSO satellites to provide high elevation angle coverage for high latitude areas, and shows the shortcomings that GEO satellites always have low elevation angles at high latitude areas, and coverage blindness in the polar region. By analyzing the influence of the IGSO satellite orbital inclination on the double satellite coverage and communication elevation of different latitudes, according to the multiple coverage of the Chinese and nearby area, and the coverage of high elevation angles in high latitudes. Slighting an orbital inclination can perform well multiple coverage, and can also provide good communication elevation angle for high latitude areas. The analysis results shows that the Constellation can provide double satellite coverage for the Chinese and nearby area more than 80% of the day. The global real-time single satellite coverage reaches more than 95%, and the communication elevation angle at two poles reaches 30 degrees. That's all. Thank you.
Hello everyone. My title is Mars Exploration Oriented Design and Simulation of Relay Communication. I will explain it in 4 parts, including introduction, scene construction and simulation of an on-orbit Mars orbiter, system of covering Mars relay constellation uniformly, and conclusion. The first part is introduction of this paper. Many questions, such as the origin of the universe and the stars, the existence of life outside the Earth, the origin of life, and how the universe will evolve in the future, require continuous deep space exploration to answer. In the next 25 years, Mars will always be the ultimate exploration target. In the 21st century, with Mars Express, Mars Odyssey, Mars Scout Orbiter, Superior and Opportunity, Phoenix, and other Mars orbiters or Mars detectors successfully exploring Mars one after another. Mars exploration has gradually become the focus of global attention. On August 6, 2012, Curiosity successfully launched on the surface of Mars. In November 2013, India launched the Maganya Mars probe into space, indicating that countries have successfully competed in Mars exploration. In the process of deep space exploration activities, a large amount of scientific exploration data needs to be returned to the Earth. As our exploration of outer space has moved further and further, long-distance, high-speed, and massive data transmission has become a major challenge for outer space exploration. If data transmission is to be carried out, a communication connection between the target detector and the ground station is required. There are 2 main communication connection methods between the Mars target detector and the ground station. One is the point-to-point communication system, and the other is the relay communication system. The traditional point-to-point communication system has already been difficult to ensure the timely transmission of a large amount of detective data, such as high-definition images and videos. Therefore, it will be a very advantageous choice to use the relay communication system to transmit various data and status information and enhance the effectiveness of data transmission. For example, the National Aeronautics and Space Administration and the European Space Agency are making every effort to build a Mars exploration relay communication network to provide communication services for various Mars exploration missions. Relay communication has been adopted from Spirit and Opportunity to Phoenix, launched in 2007, and Curiosity launched in 2012, which will become a trend of communication between Mars exploration landers in the future. The second part is the scene construction and simulation of on-orbit Mars orbiter. In order to analyze the relay communication performance of the Mars orbiter, a Mars relay network simulation scenario is built referring to the on-orbit Mars orbiter parameters. The parameters of the Mars orbiter in the simulation scenario refer to the Mars Global Prospector, Mars Odyssey, and the Mars Reconnaissance Orbiter. This is the Mars Global Prospector, which launched by the United States on November 7, 1996. After 10 months of flight, it entered orbit around Mars on September 11, 1997, and began an investigation of Mars. This is the 2001 Mars Odyssey, the National Aeronautics and Space Administration's Mars exploration satellite, whose main mission is to find signs of water and volcanic activity, and it was launched in 2001. The name of this mission is based on the movie 2001: A Space Odyssey. This is the Mars Reconnaissance Orbiter, one of the National Aeronautics and Space Administration's Mars exploration programs in 2005. The main purpose of this plan is to pave the way for future ground missions to Mars. This table lists some of their parameters. The Mars detector selected for this part of scene modeling and simulation is the Curiosity, which is a Mars detector developed by the National Aeronautics and Space Administration to explore Mars. It was launched in November 2011 and launched on the surface of Mars successfully in August 2012. It's the world's first nuclear-powered Mars detector, whose mission is to explore the elements of life on Mars. The Deep Space Station selected for this part of the scene modeling and simulation is the Kash Ground Station in China. This table lists the location information of Curiosity and the China Kash Ground Station. The location of Curiosity is assumed to be Gale. It's a large impact crater with coordinates 5.4 degrees south and 137.8 degrees east on the edge of the lowlands on Mars adjacent to the elevation plane. It's 154 kilometers in diameter and has existed for about 3.5 to 3.8 billion years. It's also the landing site of the Curiosity on August 6, 2012. In the aspect of simulation, the Mars Relay Network simulation scenario of the Mars detector to Mars orbiter to the ground station is built using the Satellite Toolkit in this paper. The link analyze module access in the Satellite Toolkit was used to simulate the visible time and link distance of a communication link. The start time of simulation is set to July 5, 2013, and the duration of simulation is 3 days. The visible time period and some parameters of the link between Mars orbiters and the China Cash Ground Station or Curiosity are obtained through simulation. The simulation data between Mars orbiters and the China Cash Ground Station are shown in the following figure and table. The horizontal continuous line segment indicates that the ground station or Curiosity and Mars orbiter are visible. The visible time and average distance of the link are summarized in the table. Visible time, link coverage, and some parameters between Mars Global Prospector, Odyssey, Mars Reconnaissance Orbiter, and the Curiosity are shown in the following figure and table. It's obvious that the link coverage of Mars orbiters to Mars detectors is very low from the above simulation results. In order to provide longer visible time and the capacity to cover Mars probe uniformly, this paper proposes a new method of relay communication. The third part is the system of covering Mars relay constellation uniformly. In order to increase the visible time of the target detector, a relay constellation system with covering time uniformly is designed. The relay constellation system consists of 3 satellites on an orbit plane. The 3 relay satellites are evenly distributed, with a phase interval of 120 degrees. The orbital inclination of 150.567 degrees, and the satellite orbital height of 3,590 kilometers. This distribution method has equal communication opportunities with target detectors, which is conducive to periodic work plan. Here are the orbital parameters of the 3 satellites in this system, including track inclination, ascending intersection, true close angle, link average distance, and a 3-dimensional schematic diagram. In contrast to this system is the continuous coverage relay constellation system, which is also composed of 3 satellites on an orbit plane. But in order to achieve continuous coverage of the target area, the satellites are not evenly distributed in the orbital plane. In order to connect the coverage time of the target detector end-to-end, a smaller phase interval is required. The phase difference between the 3 satellites is 76 degrees, which is less than 120 degrees for uniform coverage. The interval in an orbital plane is relatively close. It is more compact, so it can continuously cover the target area within a period of time. Other satellite orbit parameters are consistent with that of the relay constellation with uniform coverage. The focus of the following analysis in this paper is still the system of covering Mars relay constellation uniformly. The simulation analysis of the newly designed system of covering Mars relay constellation uniformly is carried out. The following figure and table are the visible time period and link coverage between 3 Mars sites and China Cash Ground Station. What's more, these following figure and table are the visible time period and link coverage between 3 Mars sites and the Curiosity. Comparing the above simulation data with the data in the previous part, it can be seen that when the Mars orbiter increases orbit height, the link visible time and the coverage of the link of the Mars orbiter in the Mars relay constellation system and uniformly covering has been greatly improved, and the visible time of the Mars detector to Mars orbiter and Mars orbiter to ground station has increased, which is conducive to the transmission of information and data in Mars exploration. In addition, in this relay communication system, the communication opportunities between the relay satellite and the target detector are equal, which is conducive to periodic planning. The last part is the conclusion of this paper. This paper aims at the characteristics of deep space communication, especially the long-distance and complicated communication environment in Mars exploration. This paper also uses STK to build a Mars relay network simulation scenario with reference to the orbit parameters of the on-orbit relay satellites of the United States and Europe. And this paper analyzes the link visibility and link distance of the mode. Then, a relay system with long visible time and uniformly covering the Mars detectors is proposed in this paper. The simulation results show that the link visibility and link coverage are significantly improved compared to the previous relay method. That's all. Thank you for your listening.
Good afternoon, everyone. My name is Bianyu Xie. I'm honored to attend this meeting. Our paper is multi-beamforming algorithms of LEO Constellation satellite. I will divide into the following parts to explain research background, multi-beamforming algorithm, LMS algorithm with variable step size, and conclusion. The first part, research background. Since the first international commercial communication satellite between North America and Europe, named Morning Bird, was successfully launched by the United States in 1965, the satellite communication industry has experienced full development in recent decades. Since the 1990s, the rapid development of optical fiber and mobile cellular communication infrastructure on the ground has greatly squeezed the development space of commercial satellite communication industry. Although there is a certain moment of growth, the development of its industrial scale is extremely difficult. With the coming of the 21st century, the development of mobile Internet and Internet of Things technology has brought new opportunities for the development of communication satellite industry and a new development direction with multifunctional, comprehensive, and the Internet of Things as the application goal has emerged.
The mobile broadband Internet satellite system based on LEO satellite constellation will realize the following service worldwide, including personal wireless communication, global Internet access function, Internet of Things access service, timely information throughput service, stronger navigation obligatory, and navigation innovation monitoring. The multi-beam antenna technology is indispensable in the realization of the above system, and each subbeam is responsible for covering a certain range of target areas. Compared with the traditional single-beam antenna, the multi-beam antenna has many advantages. The second part, multi-beam forming algorithm. The least mean square (LMS) algorithm is an adaptive beamforming algorithm based on MMSE criteria, which is the most widely used beamforming algorithm. It constructs a performance surface between the actual output and the desired signal through the square error under the condition that the desired signal is known, and it uses the random gradient method to minimize the error. LMS algorithm has the advantages of low computation complexity and small total computation. The main disadvantages of the algorithm is that it is difficult to choose a suitable step size to realize the trade-off between convergence speed and algorithm error. In the simulation stage, the LMS algorithm can form the main lobe of the beam in the desired direction. The algorithm achieves initial convergence after about certain iterations, and the output signal of the array can roughly follow the desired signal stably. With the increase of the number of elements, it can achieve faster convergence speed and better stability of convergence error, but it will increase the amount of conclusion accordingly. The third part, LMS algorithm with variable step size. In the classical LMS algorithm, the step factor of the algorithm is constant. The smaller the step size is, the smaller the error is, but the larger the convergence time constant is. Obviously, the fixed value leads to the contradiction between the convergence speed and the stability of LMS algorithm. The LMS can be avoided to some extent by setting the convergence condition. The convergence speed and its steady-state performance should be considered at the same time. Therefore, the method of changing step factor with time in algorithm iteration is simple and effective strategy. In order to achieve better steady-state performance in the later stage of the algorithm, the step factor of the algorithm should be reduced with the decrease of the mean square error. Therefore, it is an effective way to change the step factor of LMS algorithm to the dynamic value of error level with time. In the practical application scenario, another variable step size, lead mean square SVS LMS algorithm based on the sigmoid function has also been widely used. First, internalize the weight vector. Second, signal sampling. Third, sampling time error estimation. Fourth, step factor update. Finally, weight vector update. Similarly, in the initial stage of the algorithm, due to the large instantaneous error, the algorithm step factor is at a relatively large level, and the algorithm can achieve a faster convergence speed in the early stage of the iteration. With the decrease of the error, the step factor will decrease rapidly to improve the stability of the algorithm. Simulation analysis. Keep the simulation conditions of single beam forming unchanged. Compare the effect of SVS LMS algorithm and the classical LMS algorithm and fix the number of iterations to 100 times. From the simulation results, it can be seen that after the initial convergence, the algorithm error of SVS LMS is generally more stable than that of classic LMS due to the reduction of step factor. At the same time, the convergence speed of SVS LMS algorithm in the early stage is also slightly improved compared with the classical algorithm. The table shows the conclusion amount comparison of LMS, RLS, and SVS LMS in each iteration when the error element number of error antenna is n. It can be seen from the table that the computational complexity of SVS LMS algorithm is slightly higher than that of classical LMS algorithm, and it is also much lower than RLS algorithm when the number of array elements n is large. Compared, Compared with the classical LMS algorithm, it has a significant advantage in improving the convergence stability. It can realize the relatively stable and fast convergence of the weight when the conclusion complexity is not high, which makes the modified algorithm more applicable in the application scenario where the conclusion complexity of the low-orbit Constellation satellite is not too high. At the same time, for the large-scale error antenna with many point beams, the last part, conclusion. The simulation model of the adaptive beamforming algorithm is established based on the mathematical model. The characteristics and advantages of different algorithms are compared from the convergence speed, convergence effect, steady state error, and so on. In view of the shortcomings of the convergence stability of the classical LMS algorithm, this paper explores the improvement feasibility of the variable step size LMS algorithm and verifies the considerable improvement benefit and the acceptable increase cost of the operation amount through the simulation comparison. Based on the application requirements of multi-beam in LEO Constellation satellite, the factors for selecting the algorithm are compared. That's all I have to say. Thank you for your listening.
Hello everyone, it's my pleasure to give a presentation here. My name is Tan Tao. I'm from Nanjing University of Aeronautics and Astronautics. The topic of my presentation is the outrange probability analysis of UAV-assisted satellite-terrestrial network. As PPT shows, my presentation is divided into 5 parts: Introduction, System Model and Channel Model, Outrange Probability Analysis, Simulation Results, and Conclusion. Firstly, I'd like to introduce the background of our research. Many researchers investigate hybrid satellite-terrestrial cognitive network in recent years. Several techniques have been integrated into investigate the performance of satellite communication, such as security, overlay model, hardware impairment, person point process, relay selection, normal, and something else. However, only a few researchers investigate the performance of UAV towards hybrid satellite-terrestrial cognitive networks. Hence, the motivation of our work is to construct a lower satellite-terrestrial network, which consists of flexible UAV and multiple distributed base stations, which is more realistic in the future wireless communication system. The goal of the paper is to investigate the performance of our model with the influence of cognitive radio, UAV cooperative communication, and a combine of satellite-terrestrial communication. The challenge of the paper is the derivation of out-range probability with the influence of UAV cooperative and multipath fading interference. The contribution of the paper is that a LoRa framework containing UAV and DAS is built for downlink performance analysis. Cognitive radio is applied for satellite-terrestrial network integration, which makes the out-range probability derivation difficult. An approximate closed-form out-range probability is derived. The related simulation is implemented to analyze the proposed model. Then we will give a brief illustration about the system model and the channel model. The system model is presented as Figure 1. Where one GEO satellite S communicates with a secondary satellite user with the help of cooperative UAVR. At the same time, distributed antenna pods transmit signals to primary terrestrial user, which causes the interference to SSU under the same spectrum. Supposing the channel state information is perfectly known in our system, and the UAV is fixed during the signal transmission phase. The direct link between the satellite and the secondary satellite user is blocked due to the poor channel condition. The assumption is common in the study of satellite communication. With the aid of decode and forward cooperative relay, during two-slot signal transmission, the received signal at SSU is written as equation 1. With perfect signal detection, the signal to interference and noise rate at SSU is shown as equation 2. Before the calculation of out-range probability, we shall introduce the channel fading model in our system. The channel between satellite and UAV is modeled as shadow rise fading, with probability density function shown as equation 3. The concrete parameters can be viewed in our paper. The channel between the UAV and the terrestrial device is modeled as rising fading. The PDF and the CDF is shown as equation 4 and equation 5. The terrestrial channel fading is modeled as Nakagami fading. We also bring the propagation gain to describe the satellite transmission gain in our system, which includes free space loss and the antenna gain. All of the loads are modeled under three-dimensional coordinate system, with coordination xi, yi, zi, respectively. Out-range probability is defined as the probability that the transmitting link capacity falls below the needed user rate. Based on the above definitions, the out-range probability analysis can be calculated with the correlation of f2 of x and f7 of x shown as equation 7. Moreover, f2 of x can be calculated with the combination of f3 of x and f4 of x. With variable substitution, integral solution, and simplification, the expression of f2 of x is written as equation 9. To obtain fe of x, mathematical lemma is proposed in our paper. Supposing xi subject to gamma distribution with shape parameter ai and scalar parameter bi, then the sum of gamma distribution xi can be approximated as gamma distribution with the shape parameter ay and the scalar parameter by. Based on the above mathematical lemma, f7 of x is shown as equation 10. By substituting equation 9, equation 10, and equation into equation 7, the outrange probability of SSU can be viewed as I1 minus I2 minus I3, where I1, I2, and I3 are derived as equation 12 to equation 14, respectively, with the help of integral formula. To obtain more insights, the numerical results are provided for outrange probability analysis in simulation. Okay, now we move to the part of simulation results. The simulation parameters of our model are shown in Table 1. The satellite communications signals at the K-band with the given parameters such as antenna gain, 3 dB angle, and carrier frequency, and carrier bandwidth. The propagation gain mentioned before can be calculated based on Table 1. Besides, the terrestrial network parameters are shown in Table 2, which includes the load height, path loss index, the load location. With the parameters listed in Table 1 and Table 2, the free space path loss and the wireless channel fading can be obtained. To reveal the impact of cognitive threshold as well as the transmitting power of the UAV on outrange probability, Figure 2 is plotted. It is obviously that outrange probability decreases when UAV transmitting power increases. When ITH increases, the value of outrange probability decreases. When ITH is equal to 15 dB, the curve of outrange probability decreases monotonically. Thus, the outrange probability of SSU is worth to protect the common communication against the interference from DAS to PTU when ITH is larger. Moreover, the theoretical results agree well with simulation and a finite term summary. To make a clear insight into the influence of outrange probability with respect to the number of DA ports and the transmitting power of the base station, Figure 3 is plotted on this page. It can be found that when the transmitting power of all DA ports increases, the outrange probability decreases monotonically. This is because the transmitting signal of DA ports could cause interference to SSU. If we increase the number of DA ports, the outrange probability at SSU will be worse. The reason for this phenomenon is that when the number of the dipoles increases, the condition of terrestrial communication becomes better, which causes the common quality of SSU be worse. Finally, we investigate the outrange probability performance based on the fixed satellite transmitting power and the fixed UAV transmitting power. In Figure 4, it is obvious that the value of the system outrange probability increases when the transmitting power of the DAS increases. Moreover, when the transmitting channel at the Satellite-Terrestrial network become better, the system performance becomes worse than the previous. The main idea of Figure 3 and Figure 4 is illustrating the consequence of the terrestrial DAS networks towards satellite communication. However, even if the proposed HSTCN need to make a balance between satellite communication and the terrestrial network, air-ground integration did improve the total system transmission efficiency and expand the system coverage area. Several optimization problems for this model can be calculated to enhance system performance. Now, we come to the last part, the conclusion. In summary, this paper presents a novel HSTCN model with mathematical derivation and integration operation. The closed-form outrange probability expression of the satellite user is researched in the model. However, there are some drawbacks. For example, the locations of the SSU, PTU, and the UAV are fixed. The asymptotic expression is also needed for outrange probability performance analysis. To make the contents of our research more detailed and innovative, we would combine our proposed system with the flight characteristic of UAV and the mobility feature of terrestrial devices in the future. That's all I want to say. Thank you.
Now, for the closing of the 5th EAI International Conference on Machine Learning and Intelligent Communications, I'm going to announce the best papers of this conference. I'm the General Chair, Minxiang Guan, from Shenzhen Institute of Information Technology. And now, I'm going to announce the Best Paper Award. Goes to these 4 papers. Paper number 1, a novel non-stationary channel model for UAV to vehicle NN-wave beam communications by Kai Mao, Qiumin Zhu, Mao Zhongsong, Benjamin Baiyou Hua, Wenjie Zheng, Xiaoming Chen. And the second paper is co-channel interference between satellite and 5G systems in C-band by Xinxin Miao, Minchuan Yang. And the third paper is resource optimization for UAV-enabled multi-channel Internet of Things by Xin Liu and Biaojun Lai. And the last paper, automatic scoring of L2 English speech based on DNA acoustic models with lattice-free MMI by Dean LoRa, Minxiang Guan, and Linzhong Xia. Congratulations. These are the 4 best papers award of this conference. Thank you very much.